Okay. Now they record already.
I just wondering, this evening we do have like a paper publication for the one related to waste energy, right?
Yes.
Is
Alright.
it possible for me to give a general one, because I did not specifically do on the energy, because I will share only my experience publishing,
Yes,
how
you
did I
can.
do and everything. Is it okay?
Yeah, you can, because I think depend on your expert. You can share your skill and your expert to student. Not only energy, you can share in your field. Yes.
Yeah, it's better because it will be much more diverse. But I will try to pick up few journals that you can try. If let's say you want to publish in renewable energy, I will like list some of them that probably you can try to submit your articles. The the evening session, it will be starting at one right, 1 Thailand time, right?
Yes. And now we are 10 a.m. 10 in Thailand. Yes,
You,
and we have on morning section 2 hour, and then we need to break 1 hour and come back 1 p.m. 1 p.m. in Thailand. I'm not sure we are you sooner than Thailand, right? Your time?
yeah, we are at 11 now, 11
Oh yes,
a.m.
you are sooner. Yes.
How many are they in your class for today?
I think from period you around 10.
10.
Yes.
Okay.
Maybe they come late. So
So,
Professor, I need to attend another meeting. I need to start class
okay.
on. Yes. Good morning, student. I'm Dr. Isara Chanakel Sambun. I'm a coordinated lecturer from Queen of Songkla University from Thailand. Today we are pleased to invite Professor Sumaiya Zainal Abidin from we call short name is University Malaysia Pahang, or UMP. For online class today, she will give valuable knowledge and some her experience on publication on the title of renewable energy technology and publication. So I would like to invite our viewers concentrate to attend this class, and I assign my student Sutipong and Pirapat to help professor to conduct class. Thank you, professor.
Thank you very much, Izara. Are you coming this afternoon around 1?
I'm not sure, professor. If
Okay.
possible, I will try. Thank you.
Okay. Thank you very much. Hi. The one that will be in charge of the session would be, what's your name? Sutipong, is it? Mr. Sutipong, are you in the session already?
Yes. Yes,
Hi.
Professor.
Hi. Okay. May I start the presentation?
Okay.
Okay. Thank you very much.
Yes.
So I'll share my slides. And for this presentation, I'm going to first give some overview on waste to energy. My title will be Waste to Energy from Chemical Engineering Perspective. And in the first session this morning, I'm going to highlight on what would be the waste to energy, what would be the technology that we can use, and some of the pros and cons of having waste to energy facilities in our country. So later in the afternoon, I'm going to focus on the tips and tricks for publication. It will be general. It will be a bit general since I did not focus specifically on waste or renewable energy, but I will be listing down some of the possible publications that you can venture into when you submit a paper in this topic. Yeah. So let me share my slide first. Okay. slideshow here. Okay, everyone can see my slide, right?
Yes, Professor.
Okay, thank you very much. So I am Associate.Prof.Dr. Sumaiya Zainal Abidin. I'll be giving some talks on the innovative waste to energy technologies from a chemical engineering perspective. I'll be briefing you a bit on what are the technologies available that you might want to venture in later when you work later, or you want research that you can venture when you have the waste that you want to use or recycle. Okay, so for the introductions, waste to energy. What is waste to energy? It's a process that actually involves the conversion of the waste, whereby we want to actually get out as heat, electricity, or even a reusable or recyclable item. Yeah, waste to energy can handle a lot of waste ranges, including like municipal waste, agricultural waste, industrial waste, and many more that we can have. So apart from talking about the technologies that we can use for waste to energy, we do have few processes that is quite popular, which is incinerations, gasification, pyrolysis, and anaerobic digestion. We are going to go through each one of them later, one by one. Currently, the most common one that being used throughout the entire global would be the incineration, whereby we are burning it at a very high temperature to generate steams, whereby this can actually power the turbines and generate electricity. So WTE has been gaining some popularity nowadays, as we are having a very great or crucial situations on the greenhouse emissions, and thereby every country is taking steps in actually building a facilities of waste to energy. Okay, let us, I need to reshare, I think, my slide because I did not tick the button just now. Wait for a while. I need to stop sharing. I need to share again. Share. Waste to energy slide. Share. Sound.
Paper, plastic, metal, glass. Even if you've been really good about separating out your recyclables, there's always something left over. What happens to that? It doesn't have to go to a landfill. Waste-to-energy plants are turning trash into power. Non-hazardous residential and commercial waste is delivered to a facility where it is combusted in a specialized chamber, creating steam that drives a turbine that makes electricity to power homes and businesses. state-of-the-art emissions control systems cool, collect, and clean combustion gases. All this is continuously monitored to comply with state and federal standards. At the end of the process, metals like steel and aluminum are recovered for recycling, and remaining residual materials are beneficially reused or disposed of in a landfill. Recycling is important, but generating energy from waste is important too. Out goes the trash, and back comes clean electricity for your home.
Okay, you can hear the voice just now, right? Everyone can hear the voice, right? The voice of the video.
Yes, Professor.
Okay, yeah, I will proceed then. Okay, so we do have different types of materials for waste to energy. This is the 4 main materials that we can have: the municipal solid waste, agricultural waste, industrial waste, and sewage waste. I'm going to go through one by one later. But apart from this, I'm going to list out a bit on other ways that can be used as the WTE material. First of all, we can have the medical waste, which consists of the syringes, bandage, and other material related to healthcare facilities. As we know, they are having a special treatment for this material waste. And if, let's say, we can actually recycle them as well, it's going to be better, right? So apart from the medical waste, we also have the most abundant one, which is the electronic waste, the e-waste, or known as e-waste. Normally, electronic devices such as laptops, computers, headphones, televisions, there are a lot available, and they are the active metal that is in the e-waste normally is very difficult to separate it. That's why by converting it to energy, it will be much better, as you can have an energy apart from leaching out some of the metals to be reused again in other applications. Last but not least, not forgotten, the construction and demolition waste, whereby you do have concrete, woods, and other metal generated during the demolition process or the constructions of buildings. Okay, first of all, we look at the first waste, the municipal solid waste. This is the most common one. We are generating our municipal solid waste every single day. So what would be the best thing that you can have about this waste? First, to have this waste as a feedstock for the WTE technologies, it do have abundance of it. We are producing massive of municipal solid waste every single day, and the compositions is quite consistent, whereby we do have food waste, things that we are eating, the leftover of the food, or even the detergents that we use for laundry washings, the soap that we use to take a bath. And apart from having only organic waste, municipal solid waste also covers inorganic materials, which also can harness energy, that can be harnessed to actually generate the energy. Last but not least, resource recovery, whereby normally quite a number of materials can be recycled back from this municipal solid waste, such as metals, plastics, and other recyclable material. Normally for this type of waste, the most popular one to be used would be the incineration. And some of the latest technologies, they are even opting for gasifications and pyrolysis process. The organic waste in particular, most of them are being dumped in incinerator to actually combust them and produce products from the incineration process. So this is some of the types of municipal solid waste that we have. We do have, the most one will be organic waste, such as food waste or a yard waste or even any biodegradable waste. Yeah. Apart from that, you also have textile waste. We have plastics. We have paper and cardboard, glasses, even the hazardous waste such as batteries, light bulbs, or other materials that contains hazardous chemicals. Okay, this is the compositions of the municipal solid waste. And we can see clearly that organic matter would be the highest one, the highest percentage that they have, followed by papers, plastics, and other materials. It is very important for us to actually know the compositions of this municipal solid waste, as different countries is producing different kinds of MSW, and over the time as well, throughout the time, we know that this consumer habits is changing, and the way of the waste being managed will be changed as well. That's why the time frame and the countries need to be taken into consideration when you want to build up a facilities that actually are having this municipal solid waste as the feedstock. The second one will be the agriculture waste. The agriculture waste is from most of it the wastes from the forest plantations and anything that related to plant. Yeah. Apart from that, we also have animal manure and food processing waste, whereby this is also considered as the agriculture waste. So as there are various quality of agriculture waste, the treatment that being used is very depending on the feedstock that we are having. For example, like if let's say we have a very high moisture content or ash content, we are going to have a different treatment with waste that have a very low moisture content or even a very low ash content. Yeah, because these three elements, the moisture content, the ash content, and the calorific value, very crucially affected with the types of WTE technologies that you will use to actually produce the energy. Apart from that, agriculture waste also, we do have different seasons. Yeah, we like in our country, Thailand and Malaysia, we don't have any problems with that since both of us are having tropical countries. The same types of plants are being planted throughout the year. So because our seasons is only the rainy part and the sunny part. But if you're talking about the four seasons country, they are producing different kinds of plant at different season, making that the seasonal effect is taken into consideration when you want to build the facilities. Apart from that, you also have a pre-processing requirement, whereby some of them, they are coming in a big chunk of pieces, like log or things like that. So you need to actually make it smaller or shredding it so that it can be fitted in the facilities. Not to mention also drying, because some of the waste, the agriculture waste mostly, because okay, we take the simple examples, our country, we do have a very heavy rains in some of the seasons, and therefore some of these agriculture waste, they do have a very high moisture content, and therefore drying need to be added as a pre-treatment method before it can be it can goes to another further processing to produce energy. Apart from these the other factors that I have mentioned before, we also can look at the potential of contaminant, because we know that the agriculture farm or any plantation, they are having pesticide, right, for them to grow the plant. And that's why there will be a possibility that these pesticides will affect the processes and poses risk to human health. This is some of the examples of the agriculture waste, where we do have the crop residue, we have the animal manure, we have the food waste and wood waste. It's worth to mention that different types of agriculture waste may be more suitable to a certain types of waste to energy technologies. For example, right, we do have crop residue. Normally, crop residue and food waste, it may be suited, well suited with anaerobic digestion. Others, while wood waste may be more suitable for gasification, maybe. So the choice will be depending on few factors, such as the compositions and also as the things that been released during the process. Okay, let us see one video on the, my slide will be, we have a numbers of videos that I would like to show because it's very interesting, especially when you look at a few case studies later. I'm going to show what are the established waste to energy plant that has been built up till nowadays, till now. So you can see different types of technologies have been adopted to actually build waste to energy facilities, and some of them are very, very interesting to be looked at, and we can actually learn more from it to establish our own WTE facilities in our country. Okay, first of all, we look at this video. They are talking about the biomass, which is the waste from the agricultural plantations, and how this biomass can be converted to energy.
Forestry and agriculture are the backbones of many rural communities. Landowners grow trees and agricultural crops, and mills manufacture lumber. With every one of these products, the product itself has the highest value. Take forestry. The high-value fiber is used for lumber or paper. The leftovers or residuals, material like tops and limbs, bark, wood chips, and sawdust, are called biomass and have little other purpose. Some farmers have no other choice but to open burn the unusable parts of their crops. Forest waste can be left on the forest floor or sent to landfills where it decomposes. All of these methods of disposal cause unnecessary carbon dioxide and methane emissions, greenhouse gases that contribute to climate change. But there's a better solution for these materials. We can use these residuals to generate renewable electricity to power and heat our homes and businesses. Not only does biomass create a clean energy product that helps promote healthy and resilient forests, but the reuse of this waste material combats climate change. Unlike fossil fuels, like natural gas and coal that, when burned, release new carbon into the atmosphere, the use of sustainably harvested biomass recycles carbon that is already part of a natural cycle. Trees that grow absorb carbon through photosynthesis. When that biomass is used to make electricity or heat, the carbon is released but then reabsorbed by growing forests. Provided that forests are harvested sustainably and regrown, the carbon from biomass is a part of a closed loop. Biomass means cleaner air, more jobs, renewable energy that runs 24/7, and less CO2 and methane going into the atmosphere. It powers and heats homes, businesses, and electric vehicles. And it strengthens our communities and helps them thrive.
Okay, that's a bit on the agricultural waste. Now we are coming to the third one, which is the industrial waste. So for industrial waste, compared to other types of waste, this kind of waste would be having little bit higher energy content actually compared to the municipal solid waste or even the agricultural waste. And they are quite consistent, especially when they are coming from specific industries. Due to the high energy content that owned by these industrial waste, we can find that there will be more efficient and effective source of energy being produced when we are using it in WTE facilities. Okay, as I mentioned before, this kind of waste is quite consistent in terms of its composition because due to the nature of the industry itself. However, it will be depending on several factors such as geography or even the population density or even the consumer behavior. Because when you talk about consumer behavior, the consumer behavior will lead to the industries that are going to produce the most things that will be bought by the populations. That's why having when you look at the country, you look at what industries, you look at what the peoples are venture in or what other people likes to buy, and this will lead to that particular industry being a massive in that country. Yeah, so it's very, very crucial to actually determine the type of waste, especially in concentrated area such as industrial park or manufacturing facilities, where that you want to build these WTE facilities by using the industrial waste. So you need to identify what kind of industries involved within the area, because definitely you want to take or you want to have a feedstock that is near to your facilities, right? So by identifying the types of industry presence in that particular location, you can decide what kind of material you will produce, what are the material you can recycle, and what kind of process that you can use for the WTE facilities. So certain types of waste such as wood waste or even a construction or demolition waste, maybe some other treatments will be can be used such as gasifications and pyrolysis. And most of all, the most common thing that they will be getting from industrial waste, of some of the byproducts that they can get from industrial waste, will be the recyclable materials or metals, recovery of valuable metals, which can be used in other application after they have been extracted from the waste itself. Okay, this is some of the types of the waste for industry. As I mentioned, it will definitely depending on the specific industries and the production process nearby the facilities. However, we can actually have a general breakdown of the industry's waste, where we do have the organic, we have the biomass, we have the plastics, and we have the metal, whereby the composition would be varies, as I mentioned, according to what industries that you want to have as a feedstock for your WTE facilities. Last but not least, on the sewage sludge. Normally, the sewage sludge is a byproduct from the waste treatment, and definitely it contains lots of organic matters, nutrients, pathogens, whereby the main challenges maybe for the sewage sludge is they do have a very high moisture content, which up to 90%, that makes it very challenging to actually burn them. And that's why normally the most suitable WTE technologies for sewage sludge would be anaerobic digestion. But however, other processes like incineration, gasification, and pyrolysis can be used with the additional pre-treatment processes, which is drying process. Yeah. One more thing that might be challenge might be one of the challenges that we can have for sewage sludge would be the complex composition of the sewage, as it contains a mixtures of organic and inorganic materials, and this would be one of the challenges that will be faced by the facilities, the WTE facilities, to have the optimum conversion of the energy, since it can vary from one feedstock to another. Okay, this is a type of sewage sludge. We have the primary, secondary, and tertiary. Primary normally comes from the primary settling tanks of the wastewater treatment plant. Secondary is coming from a biological process normally. The tertiary is the additional treatment process, such as separations by filtrations or disinfections. And finally, you have biosolid, whereby this biosolids is the sewage sludge that has been treated and processed to meet the standard requirement for it to be used in other applications. As I mentioned to you before, the best one to treat this or to convert this sewage sludge to energy would be the anaerobic digestion. We will see on the process later. Okay, so we come to the point on why we need to know all these waste compositions. First of all, definitely, when you know the composition, it will affect the efficiency and effectiveness of the process, because different kinds of waste will have different energy content, moisture content, chemical compositions, and they are going, because these three elements is going to be impacted on how this waste can be converted to energy. Knowing the content also can actually ensure the technology that you have choose, because you can choose a combinations of technology, but you need to understand your waste. So it will ensure that the selections of technology will be the most efficient and effective option for you to be used in your facilities. Apart from that, it will also, if a little knowledge on the waste composition will also impact, giving some impact on the environment, such as the release of the materials or gases, hazardous materials or gases. And by knowing this waste composition, it actually can, you can understand the process, and you can make sure that these hazardous elements would not be released from the facilities. Apart from knowing on the, apart from understanding the effects on the environment, we also, the importance of knowing this waste composition is also on the planning and logistic, whereby when you know how much waste is generated and what type of waste is being generated, it will help you to plan in terms of the transportations, on the storage, and even the processing technology. Last but not least, will be on the regulatory compliance. We know that each country, they do have different strict requirement for gas emissions from the industry. And by knowing the composition, you can comply to these regulations by installing a suitable precautions, so that this regulation can be comply later when you do a startup or start operating the waste treatment facilities, waste to energy facilities. Okay, there will be 4 types of waste to energy technologies that I will be describing in these slides. We have the first one, the incinerations. The second one, gasification. The third one, pyrolysis. And the fourth one will be anaerobic digestion. Okay, on the first one, we look at the first technology, incineration. Incineration is a very famous technology. It can be used to, it's actually the most popular one. It has been used like quite some time already for, apart from landfilling, okay? However, maybe the main drawbacks is because it being conducted at a very high temperature, which is very high energy consumptions, yeah? So this heat that being produced from incineration will generate steams, and this steam will actually runs or powers the turbine to produce electricity or other energy applications such as heat or electricity. Okay. One of the best thing that you can have for this incineration would be it do reduce the amount of waste being dumped in the landfill. Normally, we do incineration, the waste, the volume of waste that can be reduced from incineration will lead to up to 90% from the waste, the total waste that being dumped. And it can also destroy pathogens because it is conducted at a very high temperature, right? So it definitely reduces the public health risk associated with the waste disposal. These are some of the special features I can say for incineration. First, we do conduct it in a combustion chambers where these chambers is actually burn all the waste at a very high temperature. And normally, nowadays incinerators, they are equipped the incinerators with a sophisticated air pollution control device, because the major maybe the major perceptions of people on the utilization of incineration would be the air pollution. Yeah, how the nearby residential affected by the air pollution released by this incineration process. So nowadays they have equipped this incinerator with a very sophisticated air pollution device control such as scrubbers, filters, even the electrostatic precipitators to minimize the emissions of pollutions from the incinerators such as the particulate matter, sulfur dioxide, and nitrogen oxide. The other thing that is good with, or the other thing that makes this incineration interesting would be the productions of the byproduct at the bottom of the incinerator, which is the bottom and fly ashes. These ashes normally being reused again as a construction material, as a concrete or even as asphalt or even as the bricks. And the research on this area has been merged quite massively these few years, and it will lead to zero waste coming out from the incinerator. Okay, let us see one video that actually are talking about incinerations.
Welcome to the Waste and Energy Company in Amsterdam. More than 1.5 million tons of domestic and commercial waste is processed here each year on 6 incineration lines. Waste lorries and trains bring in the waste. It is important for optimal incineration that the waste is of a uniform quality. This is why it is mixed in the waste bunker. Large grippers then transfer the waste mixture into the hoppers of the furnaces. The waste is incinerated on grates. This is a continuous process, 24 hours a day, 7 days a week. Temperatures range between 1000 and 1200 degrees Celsius. This heat is not wasted. It turns water in the furnace walls into steam. This steam passes through the 3 turbines at high pressure, and the turbines drive a generator. This generates enough electricity to power 161,000 homes every year. After the electricity has been generated, the residual heat is used to produce heat for the city. This is piped to the district heating system in Amsterdam and provides warmth for 15,000 homes. Part of the waste is incombustible. This part which remains after incineration we call bottom ash. Technology developed together with Delft University of Technology is used to wash and recover metals from the bottom ash. Large amounts of iron and non-ferrous metals, such as aluminium and copper, are returned to the scrap metal trade for recycling. The rest is cleaned further until clean sand and a stony granulate remain. High-quality building materials which are used, for example, in concrete and asphalt. After the incineration process, the flue gases are cleaned. This is the longest part of the whole production process. And all done to ensure that almost nothing is released from the chimney. There are strict government regulations. Emissions from the waste-to-energy plant remain well under the limits, and we continue to work on improving this. The flue gases are cleaned in a number of stages. We aim to recover useful products at each of these stages. First of all, flying particles are removed using an electrostatic filter placed behind the furnace exhaust duct. This fly ash is used as a filling material in asphalt. Dioxins, heavy metals and other environmentally harmful materials are then removed from the flue gases. Plaster and salt for de-icing are recovered in the process and used in industry. The water necessary for the process is recycled in a closed system. The installation therefore produces no wastewater. A sensor in the chimney constantly measures the quality of the discharge gases. The white plume of smoke is in fact nothing more than basically pure steam. Only about 1% of everything that enters the waste-to-energy plant is actually left over. This is completely unusable and is disposed of safely. 99% of the waste is converted into sustainable electricity, heat and useful building materials.
Okay, that we have seen on incineration, one of the plant in Amsterdam is using incinerators to actually convert their waste to energy. And you can see that even the communities also can monitor the air emissions from the facilities itself to improve the perceptions of the people on the incinerator, so that they are convinced that they are living in the safe place and they are getting the benefits from that incinerator itself. It can power the home, it can warm up the houses, which is very, very good. But if you can see from the video, it do have you do need to spend some investment, like you need to invest to build the facilities first, because this technology is quite new. It's not that new. It has been there since like 20 to 30 years before, but it's being upgraded from time to time, and the one that we have currently would be one of the most sophisticated waste to energy facilities involving the incinerations. Okay, these are some of the incineration benefits and drawback. Definitely, it will diverse the accumulations of waste in landfills. We know that landfills is cheap. You can just open a land and you just like provide a lining on the groundwater treatment plant, having the proper lining so that the sludge or the sewage sludge did not penetrate to the underground water, and you can just dump the waste there. Okay, but it incurs quite a numbers of problems. It's very different. It's very long to degrade. It's creating other emissions such as other emissions and other release of greenhouse gases, which is methane and carbon dioxide, and making the landfill is not that attractive anymore. That's why when you have incineration, it can be actually reduce the waste of volume up to 90%. Secondly, on the pathogen reduction, definitely it reduce these pathogens as it been conducted at a very high temperature. And definitely the third one on the space saving, because incinerator can treat the same amount of waste at a very, very small capacity. So definitely space saving would be one of the option, especially when you have a very small countries. Yeah. The drawbacks, definitely we are talking about the emissions coming from the incinerator. That would be the skeptical public perceptions on this incinerator. That's one of the reasons why people are actually not really interested to incineration, because of the release of the emissions, the pollutions from the incinerator itself. Yeah. A second one, definitely high cost, as I mentioned. It's a bit sophisticated as you have diverse range of wastes that can comes into the system. So you need to tailor the system or operate the system according to different types of waste coming in, and that will be making the process much more complicated. You also need to ensure that there will be no waste released to the environment. It means that everything needs to convert to something else, either from the energy point of view or even it being reutilized or recycles at different applications. That would be for incineration. So these are the things that maybe the governments, the people, even the academia should take into consideration. What should be investigated later, or what should they plan, so that these 5 elements can be solved and incineration can be used as safe as it can. First, on the ash management, you might want to have companies that opt for the technology to actually produce the construction materials with this ash. We know that the ash is going to have various properties, and that's one of the reason why waste is not getting interest from the industry, apart from the pollution awareness. Yeah, but people nowadays realize that having too much waste or too much pollutants on the environment will actually affect making the earth becoming sick days by days. That's why people do have this concern and awareness, and therefore they don't mind to actually take precautions or going through an innovative steps to actually reduce this waste. Second, on the emission reduction, definitely to design a very sophisticated air pollution control to make sure that the gases is not being released, energy efficiency, we need to actually maximize the energy. The energy definitely will be varies according to type of waste that you have. Fixed stock variability, your plant need to be able to be tuned according to the types of feedstock that is available. The operational flexibility, it must be flexible for them to operate different kind of waste, and not forgetting the corrosion, because some of the feeds, they might be corroding the facilities or the reactor, or even the construction materials of the plant. So you need to take precaution on this, how to actually solve this problem for the commercial skills plant. The second one, we talk about the second technology, which is the gasification. So gasification is a process whereby you are having a techniques that actually converts the energy into a gas mixtures, or known as a syngas or the synthesis gas. So this process actually involves the heating of the waste in the absence of oxygen, which cause it to break down into usable parts. Yeah. So gasification is normally able to convert a wide range of waste materials like MSW, agricultural waste, even industrial waste, and the product that coming from the gasification will be various. We have a syngas, which can be used to generate electricity, or even as a fuel, or even as a feedstock for the chemical processes. We also have the we do have the ash that produced from these facilities as well. And with this this gasification process, it actually offers a bit higher energy efficiency and lower emissions of pollutants as compared to other WTE technologies. Okay, this is some of the special features of the gasification. We do have the resource recovery. Okay, there are a few types of resource that we can actually obtain from this gasification. The first one would be the syngas. Okay, syngas would be the major feedstock that will be produced from gasification. So the syngas can be either used as a heat or generate electricity, or can be used to generate electricity or heat, or even can be used to produce methanol, ammonia, hydrogens, or other materials such as carbon black or activated carbon. In this process, we also will obtain biochar, where this biochar is normally being used as the soil amendment or as a carbon sequestration tool to actually mitigate the greenhouse gases. The third one that normally being recovered from gasification would be the metals, because we know that some of the waste stream, they are rich in terms of zinc, in terms of other minerals like lead, which can be extracted and be reused in other application. And last but not least, recovery of nutrient, maybe not much, because this is conducted at quite a high temperature. So some of the nutrient will be there to produce fertilizers, but will be only a little bit compared to anaerobic digestion. It is classified as one of the competitors for the incineration technologies, whereby they are generating a much more energy efficient compared to the traditional incineration process. In terms of let us see on the this video is talking about gasification. we'll see how gasification works in this particular video.
Globally, people are increasingly aware of the environmental consequences of poor waste management and disposal. Problematic landfills, pollution of our land, underground water, lakes, rivers and oceans, and harmful emissions, including substantial greenhouse gases released into the atmosphere. These consequences are compounded through increased populations producing ever more waste. Current waste disposal methods also demand the expanding use of polluting heavy transport to move waste to often distant disposal sites. Fortunately, there are solutions, including lifestyle changes to reduce waste, better education in regards to waste recycling, and applying technologies that better process non-recyclable waste, and better still, convert it to energy. Eco-waste vertical rotary gasification is a proven and commercially successful process that converts solid waste to baseload electricity without odour or harmful emissions at a locally situated facility. The truck is driven into the facility building and tips the waste into a fully enclosed pit. A grab crane deposits the rubbish into the vertical rotary gasifier, which runs at white-hot temperatures in a low oxygen environment. The majority of the waste instantaneously converts to a gas called syngas, similar to natural gas. Any remaining solid waste is used as fuel to maintain the vessel's high temperature. Slag and ash production is minimal due to the efficient and well-controlled combustion process in the lower part of the vessel. The restricted oxygen means the highly volatile syngas is prevented from burning and is sucked out of the chamber into the syngas combustion vessel. Here it's combined with large volumes of air, increasing the temperature to around 1000 degrees centigrade. These extremely hot gases flow into a heat exchange boiler where they are cooled by converting water into superheated steam in an enclosed loop system, which in turn drives turbines to produce electricity. Finally, the exhaust gases from the heat exchange are cleaned to neutralize acids, activated carbon, and any small particles of fly ash. The gases pass through a large filter bag before being exhausted through the stack, essentially as nitrogen gas, which naturally makes up most of our atmosphere. Importantly, as part of the quality control system, the stack contains inline sensors which precisely monitor emissions. Any variances are immediately detected and appropriately adjusted through online controls to ensure all emissions continue to be environmentally safe. Our partners, who are based in Australia, have evaluated the gasification process in detail to ensure it meets the highest EU and Western-based government and regulatory authorities standards. The key advantages of the eco-waste waste-to-gasification energy system include a proven, audited, best practice commercial system that's been successfully operated in several countries for over a decade. Collecting and processing the waste locally eliminates thousands of waste truck movements through cities to large landfill and incineration sites. Gasification requires a much smaller land footprint to efficiently process the expanding need for rubbish disposal. Significant electric power is generated for local communities, and water used in the process is continually cleaned and recycled. Modular processing lines mean continued plant operation during maintenance. The plants are designed for long-term use and can be refurbished without closure to ensure operations in excess of 30 years. The system provides a clean, sustainable and efficient waste-to-energy solution, and it provides a transparent waste management process that can be monitored externally by local government and regulatory agencies. Eco-waste, the smart waste-to-gasification energy solution.
Okay, when we look at the most of the waste-to-energy facilities, they normally have this online air pollution monitoring, so that all the bodies that actually checking on the compliance with the regulations. They can be checked at any time so that they are complying strictly with the air emission limits that being imposed to the facilities. So that will be a very transparent action, so that we can gain trust from either from the government, from the people, or from the legislative bodies that actually give the permission for us to build that facilities. Okay, so this is some of the benefits and drawbacks of the gasification. I do have actually one video talking about this later after this. Just want to highlight on the good thing about gasification. Even though the process is quite similar, but I believe that gasification is much more attractive, as it can produce a more efficient energy compared to the traditional incineration technologies, and able to actually handle a quite wide range of waste. So, sorry. The most technical challenge would be on the complex process, as we know that every single waste to energy facilities, they do have challenges in terms of getting a different kind of waste at every and each time, making the process need to be tuned so that it can fit with the current setup that we have. That's why having a plan with a good flexibility, able to actually reduce the capital cost, definitely going to be high. But maybe when you have a very sophisticated facilities, you are able to tune around your feedstock to different properties of the feed coming in, or even different setup of the temperatures and pressures being used. So I believe that would be reducing the operational cost that will incur to that particular facilities. Okay, this is one video that I have found on the differences between the gasification and incineration. Maybe this will be showing a very clear let me see, there is some check. Okay, one of the students is talking about the gasifications of biomass in Nepal. So later when I browsed through the case studies, you can see that there is quite a number of successful gasification waste to treatment facilities that use gasification as their one of their option, because in waste to treatment facilities, we do have some of them opting for incineration, some of them opt for anaerobic digester, and some of them do the gasification. The latest one, most of it, I can see that they are focusing on the gasification of the biomass, and they claim that they have a very good revenue from that particular process. I'm not sure how true that will be, but it has been everywhere in the YouTube. It's supposed to be true, because you cannot say that you cannot publish something that is not true, supposedly. Yeah, so we can see on how they actually do a management on the byproducts, which is tar, from that particular system. I'm not sure, some of them they do mention about their byproducts, some of them they don't mention. Normally people, nowadays researchers are still investigating on this biomass tar, because I know that will create a very large problem definitely on the process itself, because it will create a massive pollutions and clogging of the reactor itself. Yeah, that would be, I can see that quite a number of researchers are still investigating on this matter. So later we can see on what we can actually suggest, or from the knowledge that we have, we might want to suggest some technologies that actually could give some better options for these facilities to be working. I'm sure having a gasification in waste to treatment, waste to energy facilities is not that conventional, which is incineration. They have a lot of them, but gasification recently, in like 10 to 15 years back, they start to actually putting the IGCC in the waste treatment facilities, the waste to energy treatment facilities. Let me show you this is the differences between the gasification
can
and
convert municipal
incineration.
solid waste into energy and valuable chemical products. It's a clean alternative to conventional incineration and works in a fundamentally different way. Incinerators use large amounts of air to burn municipal solid waste. They produce pollutants that can only be cleaned up after combustion, and they leave behind ash that must be carefully disposed of. The heat generated by incinerators is used to make steam and generate electricity. Gasification doesn't actually burn the municipal solid waste. Instead, it breaks the molecules apart with heat and a very small amount of air or oxygen, and then recombines them to form syngas, a clean fuel similar to natural gas. It's these chemical reactions that make gasification so different from incineration. The syngas can be used to make fuels, chemicals, fertilizers, and consumer products, and to generate electricity.
Okay, that is some of the differences between the incinerations and the gasification. We are going to proceed with the next slide. Okay, gasification, the future challenge, definitely on the tar formation, as mentioned by your friends just now. We must design a system that actually could effectively remove the tar and make the process more efficient. Definitely, this is one of the future challenge that we have. The feedstock variability, we know that it need to be able to handle a different range of feedstock. This is the most, I think, the common problem or challenges that we have in all WTE facilities, because different feedstock will have different energy and different energy efficiency as well. So not different energy efficiency being produced from the system. So it's very crucial to actually make your plant flexible as it can, so that it doesn't disturb the productions of energy. Contaminant, definitely this is why you need to know your compositions of the waste. The gas quality, it needs to be installed with a very appropriate or advanced separators at the end of the gasification process, so that the quality of the air can be controlled. Yeah. Corrosion, the same problem. We do have corrosion with different feedstock variability. And last but not least, it will be the scale up technologies, because that's we can say that there isn't much expert that can actually do the scale up version of this gasification. But we need to still digging so that we can establish a good study and implement it in the commercial scales. Because I believe that for pilot scale, it will be not a problem. Even for pyrolysis, we can even have a mini pyrolyzer in our homes, like in our institutions. We can even have the mini version of that in our universities. But to have a very large and commercial plant, that would require a complex process, as you need to make sure that all the waste is not being released. You need to able to convert everything to energy, or even not everything. It need to be disposed as a safe materials rather than having another types of waste coming in from the WTE facilities, which you don't want to have. Yeah. The third one is on the pyrolysis. Pyrolysis, when we talk about pyrolysis, we often think about plastic, right? Because nowadays, plastic pyrolysis is the most famous materials that being pyrolyzed to actually produce energy. Pyrolysis, we know that we do have 3 different products that can be produced. First is the gases, which is the syngas. Second would be the char, and the third one would be the bio oil. 3 products. Yeah, the composition of this product will depend on different types of pyrolyzer that you use. It can be a flash pyrolyzer, a fast pyrolyzer, or even a slow pyrolyzer. Each one of them will actually varies the composition of each bio oil, biochar, and syngas. So it's the same concept. You still need to burn the waste, but it will be operated a bit lower compared to incineration, around 400 to 800 degrees C. And normally the things that they pyrolyze commonly would be, nowadays would be plastic. They also do a pyrolysis of biomass and even a rubber. Yeah. Okay, this is some of the special features. We know that pyrolysis requires it to be conducted in absence of oxygen or low oxygens. It also can be tailored. The temperature can be tailored according to what product that you want to produce from the pyrolysis itself. So if you have, if you want to have hydrogen or the syngas, you might want to opt a different technologies of pyrolysis compared to when you want to produce bio oil from the pyrolysis process. Yeah. What else? Okay, compared everything except incineration, they produces lower emissions of air pollutants. Yeah, which saying that incineration will produce the massive air pollutants in the system, from the system itself. So by having either gasification, pyrolysis, or even the anaerobic digestion, you can have a much lower pollutant emissions from the process. Okay, some of the clips on the plastic recycle, and to see how this actually plastic can actually produce energy.
Chemical recycling of plastic waste by fast pyrolysis. New technologies are needed to handle plastic waste and recycle it back to new plastics in the future. One of the most promising chemical recycling technologies is pyrolysis, which has the capability to handle also more challenging waste plastic streams. In pyrolysis, the degradation of organic materials takes place under the effect of heat and in the absence of oxygen. To obtain high wax and oil yields, good temperature control, and very efficient heat transfer to plastic particles is needed. This can be obtained in a fluidized bed reactor, where a fluidization gas is used to mix the plastic particles with the hot sand at around 600 degrees Celsius. Nitrogen, steam, or the product gas are typically used as the fluidization gas in the process. After the pyrolysis, reactor cyclones are used to separate char, sand, and inorganic materials from the gases before the quenching of the product vapors. For product quenching, scrubbers, impact separators, and electrostatic precipitators are used to cool the gas and separate the liquid droplets from the non-condensable gases. Depending on the process conditions, pyrolysis yields typically a mixture of wax and liquid as a main product, which can be further upgraded into chemicals, fuels, and new plastics in an oil refinery. Besides liquid products, a hydrocarbon-rich gas is also produced, which can be used for olefin production or in the pyrolysis process for providing energy for heating. Upgrading plastics pyrolysis waste by hydrotreating at VTT. Plastics pyrolysis oil typically contains several impurities, such as metals, halogens, acids, oxygen, sulfur, and nitrogen, depending on the quality of the feedstock. These impurities need to be removed before the oil can be recycled and used for the production of materials. In the hydrotreating process, the plastics pyrolysis oil and hydrogen gas are preheated and pumped through a tubular reactor. The preheated feed flows through the fixed catalyst bed where the impurities react with hydrogen gas, producing water, ammonia, and hydrogen sulfide, among others. Acid groups and double bonds are hydrogenated. The reaction takes place in the catalyst bed at elevated temperatures ranging from 300 to 400 degrees Celsius and elevated pressures ranging from 30 to 100 atmospheres in the presence of a catalyst containing of an alumina base impregnated with cobalt, nickel, and molybdenum. The hot reaction product stream is cooled before it flows through the pressure controller and undergoes a pressure reduction down to about 3 to 7 atmospheres. The resulting mixture of liquid and gas is separated by pressure reduction. The oil phase contains the upgraded oil product, which can further be upgraded and fed to, for example, a steam cracker. VTT possess a 4-folded hydrotreating unit suitable for upgrading plastics pyrolysis oils by contacting the oil with hydrogen in the presence of a selected catalyst. There are 4 parallel reactors, which allows testing of 4 different catalyst or process conditions simultaneously. The diameter of the reactor tubes is 16 to 19 millimeters, which makes the testing of industrial-size catalyst extrudates possible.
Okay, this plant, they do have a very small scale reactor. You can see that the size of the reactor is quite small, which is only 2 centimeters around that. But I'm sure that will be some other pyrolysis plant that has been developed for the plastic pyrolysis, at least a pilot scale, because I do have a friend that actually produced a portable pyrolyzer at one of the automotive companies in our country. They do have a reactor or portable pyrolyzer that can actually treat the waste in that particular location, which is industry, to convert it to bio-oil in that particular case. Yeah. So this is some of the benefits and drawbacks of the pyrolysis process. We know that pyrolysis, it can actually be in size. The operation size would be, operation scale can be various. It can be a very small scale, it can be a pilot scale, or even it can be a large scale industrial facilities. It is a very straightforward process because you just burn the items according to different sets of temperatures or even different catalysts that will make different products for you. That would be the best thing on pyrolysis. And you can have like various of products that can be covered. But I can say that in most of the research, even when we did a research, the product quality that we obtain for the pyrolyzer will be much more lower, not much more lower, it will be slightly lower compared to other chemical processing, such as either reforming or gasification. Especially on the biochar and bio-oil being produced, it doesn't really produce a very good bio-oil as compared to other treatment or other processes. Yeah. Feedstock limitations. We do experience this when we do a simulation study. We did a simulation study back last year, I think, on the having a different types of plastic waste in our system. When you do have a very diverse plastic waste coming to the system, you might having troubles in terms of getting a right compositions of product from the from the process. So when you do have some certain numbers of feedstock that do have maybe a high moisture content or even a high organic content, it's not possible for you to get the optimum product yield or conversion. Energy efficiency will be lower compared to other WTE process. And it can be considered to be a little bit expensive compared to the traditional incinerations, because we do need a sophisticated equipment and the technical complexity that comes with it. Yeah. One of the maybe still a real challenge is to actually scale it up to commercial application, because the main barrier of actually scaling up the pyrolysis process will be on the cost, the high cost of the capital that you need to actually build the plant. Okay, this is some of the future challenges. It will be more or less the same as what we have for gasification. The last technology that I would like to discuss would be the anaerobic digestion, whereby for this anaerobic digestion, normally we are actually breaking down the organic matter into energy. Okay, we are normally this anaerobic digestion is being used when you have a very high compositions of organic matters in your waste. So they are using microorganisms for the treatment process, and the waste that normally being used to actually that commonly being or adopted for the technology would be the food waste, agriculture waste, or even a sludge. Yeah. So there will be 4 processes in anaerobic digestion. We have the hydrolysis, we have the acidogenesis, we have the acetogenesis, and we have the methanogenesis, which each of them will be carried out with different types of microorganisms. So these organic matters will be actually break down into few elements or few compounds, such as carbon dioxide, water, methane, that actually can be used to actually generate electricity and heat. Normally, the other product that being produced would be the biogas, where this biogas can actually reduce the release of greenhouse emissions, methane. Just now we have a methane at the output from the anaerobic digester. And apart from that, there's another interesting element or another interesting byproduct that is being produced for anaerobic digestion, which is the digestate. Digestate is the leftover food waste after the anaerobic digestion takes place. So you have the leftover or the residual. We know it as a digestate, and this digestate is very rich in terms of the nutrient, and normally they are being converted as the fertilizer. So the special features of this anaerobic digestion, one, they did not require a very high temperature, so it will be low in terms of operating costs. Second, it can treat any types of organic wastes. So you can actually put any organic waste inside the anaerobic digester, and it can, it might be that you need to tailor around with the microorganism that you have to make sure that they did not die inside that particular waste. So you need to choose a suitable one so that it will be efficient enough to convert it to energy. It has a very good setup, flexibility, whereby you can have a very small scale at home. I have been once did a digester by using my food waste, and they are working as a fertilizer. And it can goes up to a high scale or a pilot scale or even an industrial scale for this anaerobic digestion process. It is very reliable and stable source, and it doesn't being affected by the weather or even the external factors. And it's a proven technology because quite a number of systems that actually has been used anaerobic digestion as their source of waste to energy technologies for them to convert it to valuable products. Yeah. These are some benefits and drawbacks. I could highlight some of the benefits would be the low emissions of the gases. You are emitting a low greenhouse emission compared to when you burn your waste in incinerator or even in gasification or even in pyrolysis. You are having an organic waste treatment, very suitable when you want to create an environmental friendly process. And you also have the co-digestion, which allow for the multiple waste stream and treatment of a very wide range of waste. It also can be actually combined with different types of waste treatment to actually make the process more sustainable and circular economy. But the major drawbacks would be the limited waste sources. It means that it's very hard to actually obtain the continuous supply of organic waste, because normally I'm not sure in some of the countries, in Malaysia, we did not yet implement the segregation. We have implemented the segregation of waste, but it's not as effective as what we can find from European countries or even from the US countries, where they do a very good segregation of waste. So when you don't have a good segregation of waste, like a mix of waste in your household waste, it's very difficult to actually get a massive numbers of these organic waste to be put inside the anaerobic digestion, except that you might want to have this digester in your farm, like you have animal manure, or you do have the segregation of waste in the canteen of your institutions or things like that, then it might be able to actually sustain the supply of the waste. Secondly, would be definitely the capital cost. In every single new facilities of WTE, we definitely face this one, because you need to establish a complex process that requires you to cater different types of waste. And last but not least, the challenges would be on the sensitivity of the process, because we know we are dealing with microorganisms in anaerobic digestion. So we are dealing with the living things. So it will be like us. Sometimes we are happy, sometimes we are not happy, sometimes we are grumpy. So that goes to microorganism as well. So if we change, the pH is not suitable, they can't grow. If they're having a very high temperature, they die and things like that. So it's very crucial to actually, because the process is very sensitive on the temperatures and pH. That will be the two things that will be affecting the efficiency of the process, apart from the organic loading rate. So we need to have a very skilled operators and maintenance staff to actually ensure that the operation is smooth and they'll be minimizing the failure of the system. Yeah, that is on the drawback of the anaerobic digestion. I'll see, there is one university that actually implemented this anaerobic digester in their institution. They also have this, I think it's in Australia, I think. They also have the programs on the either veterinarians or something with animals, something related to animals and something related to farming. So they're actually supplying everything, circulating everything within the institution, which creating a good cycles of waste being produced and reused again as an energy. So we can see from here, let us see one of this invention in Michigan State
South
University.
Campus anaerobic digester at Michigan State University aims to reduce odor and emissions from manure, food waste, and biosolids, create a closed cycle for recycling organic material, and generate renewable energy. The digester will use a mix of dairy manure, dining hall food waste, biosolids, which are nutrient-rich organic materials, and other organic material from campus and the greater Lansing area. Once delivered, the food waste and biosolids will be heated at 160 degrees Fahrenheit for 1 hour to eliminate any potential pathogens. The material will then be mixed with manure from the MSU Dairy Teaching and Research Center and pumped into the digester. The anaerobic digester is a sealed, airtight tank which can hold 300,000 gallons. Organic material will be heated to 100 degrees Fahrenheit and will remain in the digester for 20 to 30 days. Inside the tank, mixers in the digester evenly distribute microorganisms. These microorganisms break down the mixture, producing biogas and nutrient-rich digestate. Biogas, which is roughly 60% methane, is a form of renewable energy which will be used to generate electricity. The system will generate enough electricity to offset the MSU Dairy Teaching and Research Center, around 300 kilowatts per hour, with enough left over to help power MSU. The capturing and use of biogas will generate energy, shrink the carbon footprint of campus, and improve sustainability. What's left from the process is digestate, the nutrient-rich mixture that will be held in the final storage tank until it can be utilized. Mixers in the storage tank will minimize settling for the potential 2.7 million gallons of digestate. Any unused biogas can also be stored in the sealed headspace. The nutrient-rich digestate will be used to fertilize croplands or other biological treatment processes to fuel research opportunities. By utilizing anaerobic digestion technology, the organic materials from MSU will become resources. Renewable energy is created while odors are reduced and emissions are eliminated. This project is one example of how Michigan State University is actively working to improve sustainability.
I can say that it is very interesting technologies that have been adopted by the institution. Maybe one day in Malaysia, in UMP as well, we can have that particular facilities in our institution. It is good because the universities, they do have variation in terms of programs that they offer. Like they do have the one associated with the plantations, the one associated with the animals, the one associated with the energy. I'm sure they do have the engineering department as well. So it will be much more interesting to actually having circular technologies being produced and reused in the same institution. Okay, this is some of the future challenges. Definitely, I think that will be the same, except from the feedstock competitor, because nowadays it might be that the organic waste that being used in anaerobic digestion, it also being used as animal feed. So there will be a competition between the food chain from the animal with the one that we want to produce the energy. The same goes to the feedstock quality. As I mentioned before, it does requires a very good and steady supply of high content of waste, high content of organic matters waste, which actually going to be one of the challenges, technical challenges on the properties or the conditions of the reactions. And public perceptions. Yeah, public perceptions is with ED would be on the release of odor, noise, and some other air emissions that actually disturb or affected the public, that makes the process undesirable. Okay, this is the overall benefits of waste to energy technologies, reducing in terms of waste. We are getting benefits in terms of economic, which is especially when we are conducting it in a rural area, yeah, because it gives some jobs to the people to actually work with. And apart from producing energies, it also can be supplied to the poor in terms of the electricity or heat within the system, or the homes, because some of the countries, they do have 4 seasons, right? So they do have seasons where they do need heat as the to actually make themselves comfortable in the house. And that's why this waste to energy facilities, if it's been located in the rural areas, it also can actually being reused by the committee. Definitely it will be a sustainable waste management. We want to actually have a solution to all these generation of waste. We are having, I think, people or countries like small countries like us, I'm not sure Thailand would be bigger than Malaysia, but still considered to be small compared to other big countries. We do have problems of lands later when the waste is keep increasing and we don't have enough landfills to actually dispose our waste. And apart from that, landfillings is also creating toxic compound from the release of odor, from the release of greenhouse gases, and making the process is not interesting or not attractive anymore. Yeah. This is summary on the challenges. Definitely high capital costs, it being one of the major concern when we talk about gasifications and things like that. Technologies barriers, definitely different technologies have different requirements and limitations. You need to understand your waste. You need to determine what kind of waste that is enough to be supplied to that particular facilities, and whether there is too much fluctuations on the properties, that one need to be considered as well. There will be environmental concern, especially on the air emissions. I think air emission will be one of the major concern that you do have in most of the WTE facilities, and that's why you need to have a very sophisticated separations of odor or odor control in order to make the process better. Okay, this is some of the differences or comparison between the conventional and waste to energy facilities. Definitely the first one would be the landfill, the use of landfill. We know that maybe by having a conventional method, they don't require sophisticated technologies, and it's much more cost effective compared to the waste to energy technologies. But the waste to energy technologies, they are actually reducing like 90% of the waste. So we need to actually make a judgment based on not only one factors. There will be several factors that will be contributing to why we need to convert to waste to energy. Infrastructure, definitely the conventional one, there are various of them that we have landfill in each and every of the country, lots of them. And the one with the more modern or waste to energy facilities, they are still new. The technologies are still new. It makes the process much more expensive, and therefore it takes time for you to actually establish. But we need to go to that route now, because environment is become more sick and not getting better. We are having lots of greenhouse emission. Our ozone layer is being depleting, and it's not the UV lights is actually penetrating towards the ozone layer, and we need to do some things on that so that later it will not affecting our next generation, our children's, even the smaller or the future generations of our country. So I'm going, what time is now? I think we have another 20 minutes. I'm going to skip a bit on the environmental impact. I can give the slides later for you to read. There will be 4 types of environmental impact that we can have for waste to energy. We can have air emissions, we can have ash residue, we can have water pollutions and noise pollutions. So later, if you have some time, you can have a read. But now I want to show to you some of the case studies of waste to energy facilities that we have, so that we could have some idea on how this waste to energy facilities has been implemented in all over the world. Yeah. So I'm going to see that there will be like more than 5. I'm putting here 5 because later I found that there were few more interesting ones. So I did not do anything with the slides. I just proceed by putting the case studies inside the slides. The first one is the one located in Copenhagen, Denmark, which a very unique waste to energy plant. I will show you 2 videos. I would like to show only one actually, but the videos that they have would have different things that you can see. So I would rather I would like to have you to have a look at both of them, so we can see on how these kind of waste to energy facilities can attract people, because people keep coming to this place. Because normally when you have waste to energy plants, as in Malaysia as well, people are avoiding to actually come to that place because they say that there will be public perception saying that there will be a release of gases, hazardous gases. They don't want to build up the facilities nearby the waste management center or the waste to energy facilities. So a public perception has been reduced by this kind of establishment of waste to energy plants. Yeah. This major big waste to energy plant has been built in 2017, and the unique thing is they do have this ski slope in the roof that actually open to the public. We can see. I can open it now. I want to open this one first, so we can see this one first, and later we can see more on the slides slope at the next slide, yeah, at the next video.
We're in Copenhagen, Denmark, and behind me is Copenhill. It's a waste-to-energy plant which turns the city's rubbish into heat and power. But one of the most remarkable things about it is that there's a dry ski slope on the roof. It's been designed by Danish architects Bjarke Ingels Group, or BIG, and the whole point is to create a dual use for the building and to make one of the least desirable places in the city, the place your rubbish goes, into somewhere people actually want to visit.
My name is Bjarke Ingels. I'm the founder and creative director of Bjarke Ingels Group, or BIG, and we are standing in Copenhagen on this human-made mountain where you can hike, you can ski. What's even more unique about Copenhagen is that it's the cleanest waste-to-energy power plant in the world. There are no toxins coming out of the chimney, just some steam. In this case, the innovation is the clean technology. So that meant that we could completely reimagine what does a power plant mean.
My name is Jacob Simonsen. I'm the CEO of ARC. Here we produce so much energy that we are able to make 19 Olympic-sized swimming pools boil from 0 to 100 degrees every day. We treat waste from Copenhagen and 4 other municipalities in the greater Copenhagen area. We service about 680,000 people every day. We get about 250 to 350 trucks a day. The waste is then dumped into what we call the bunker. From the bunker, it is feeded into the furnaces. The furnaces will burn. When it burns, it will heat up the district heating water. And the other part of the water goes into steam, and that steam runs a turbine. The last piece of the process is the scrubbers, the big towers you see out here. It is actually an acidic shower with calcium to take out the environmental hazardous products before we emit clean air and water vapor to the environment.
In the city, you know, you're not supposed to walk on the grass. You have to wait for the green light. You can't climb the facades of the buildings. On this building, all the things that you're normally not supposed to do, you're actually more than welcome to do. At the tallest moment, almost 100 meters, there is the tallest climbing wall in the world. Here you actually have an elevator that takes you from the foot of the mountain to the peak of the mountain. You can look out over the city as you rise. You can look into this cathedral of waste to energy. All along the perimeter, you have more than 200 trees. All the species have been chosen so they can endure the climate almost 100 meters up in the air. So it's this kind of natural meadow. It feels like a little slice of Switzerland in the middle of Copenhagen.
Copenhill is a great example of Bjarke Ingels' concept of hedonistic sustainability. This idea that just because something's rooted in sustainability doesn't mean it can't also be fun. And you don't have to sacrifice comfort or enjoyment to do things that are good for the planet.
It doesn't have to be a dirty, polluting, big, ugly box that casts shadows on the neighbors and blocks the views. The most sort of exciting and dramatic park in the city is now sitting on a bedrock of a power plant.
I love when he said that it's the waste to energy facilities should not be the black box ugly thing that you will avoid, but something that is interesting like this. So I will show you another video on this one. I love this one because they are taking from the a good photographic sites of a skiing at these particular facilities. So I would like to show to you as well this one because it is very interesting apart from what they have explained, that the founder has explained with this kind of facilities.
This video was sponsored by the Nick Morn Foundation. This is the world's cleanest waste-to-energy power plant, and it is also the world's first power plant to have a ski slope installed on the roof. It is known as Copenhill, and today we have came to Copenhagen to take a closer look at this project and show you how the Danish are transforming their waste into clean energy. Welcome back to Going Green. In this episode we are in the Danish capital visiting a project known as Copenhill. Every single day this power plant receives 300 truckloads of unrecyclable waste. This amounts to 400,000 tonnes of rubbish per year. As we all know, we need to recycle as much as we can. However, there will always be products which can't be recycled, such as food waste. Finding a new use for these products has been a major challenge for mankind over the last 50 years, as we have ended up dumping this rubbish onto land to create landfills, which are huge areas covered in waste that cannot biodegrade due to the lack of oxygen in these sites. Burning rubbish to create energy is not a new concept. However, it's never been done in such a sustainable way. This project was designed by the Bjarke Ingels Group, also known as Big Architects. Their aim was to turn one of the most undesirable places of the city into one of the most desirable. They aimed to create a waste-to-energy power plant that would only emit non-toxic steam. This would then mean that it could be safe enough to be used by the public for additional purposes. In this case, the building also doubles up as an artificial ski slope, which can be used all year round by the public. Here is a short clip of a professional freeskier going down the building. The steam that is coming off the power plant is claimed to be as fresh as mountain air. This project is an example of what is known as hedonistic sustainability. This means that you don't have to sacrifice comfort or enjoyment to do the things which are good for the planet. We got the chance to have a look inside of the building to see exactly how they were converting so much waste into clean energy. Allowing this public access to a facility which is usually positioned so far out of public sight is a great achievement on the sustainability front, as it showcases to the public exactly where their waste is going. This creates a level of accountability for all of the citizens in Copenhagen. The plant is so efficient that they even import trash from other countries. To simplify the process that goes on inside, the rubbish is brought onto site, then burned as fuel to heat up water. This steam then runs a turbine which produces heat and power that services 680,000 people every single day. The toxins produced from burning this waste is cleaned, and all that is released into the atmosphere is steam. Some of the key messages that can be taken away from this project are that sustainability and enjoyment don't have to be two separate things. They can and should coexist. Also, we don't need to hide facilities from the public eye, and instead we should highlight them and provide further education to the public so that they can become more aware of how their individual actions have an environmental impact. Thank you for watching this video. If you enjoyed it, please leave a like, and if you want to see more sustainable projects, then make sure you subscribe to the Going Green channel. I'll see you in the next video.
I love when they say that you don't have to hide this kind of facilities from the public. It means that it cannot be a thing that will be avoided by the publics. And the way that the Danish actually put out waste to energy facilities in the middle of the Copenhagen is very, very interesting. So that people are coming every single day to actually skiing. Even they are putting the snow on top of the ski slope during the winter time to actually artificial snow, I mean, so they can actually ski on top of that. So that is very, very interesting. One of the most interesting WTE facilities that I can find from the internet. So we gone to a few more. We have I have another like a few more minutes. I'm going to go first. There will be one in China, but I don't have the video on this. This one is actually using it doesn't really mention on what types of technology that they have been used inside the system, but they do have this pollution control technologies that being adopted with this plant so that it will be releasing a very clean gas emissions. So we can see this is how it looks like. It looks sophisticated. Most of the WTE plant or facilities that I browsed through, they do have a very unique design that makes people want to visit. So that will be one of the attractions that they are trying to improve the perceptions of the public so that people are not afraid of this kind of facilities. The second one would be in Vienna, Australia. This one is quite interesting as well, which is quite nice as well. I can't find anything. The videos on this one is very rare. I can only find pictures, and some of the pictures they did not show the full. You can't download the pictures because there will be some restrictions. There will be one with our neighbors, the Tuas Source Incineration Facilities. This one is in Singapore, whereby they use this waste to energy system, which recovers from the incineration. They are using incineration as their technologies to actually let me go to the, I think I would like to show you the Dublin one. This is the Norway plant. These are using incineration as well, these facilities. I want to show the one that using gasification. I think this one is using, wait for a moment, this is a Mexico one. Let me see what is the I'm not sure. Let us see what it does it. What does it? This is quite interesting as well, actually.
process begins at the reception yard, a fully enclosed site to avoid the emission of odors to the outside, with capacity to receive 20 walking floor semi-trailer trucks simultaneously. Received will be mechanically transported through the use of overhead cranes to the feed hoppers, which are connected to the combustion grates, and where a controlled temperature of over 1,000 degrees Celsius is maintained. The resulting combustion gas will exchange heat with boiler water tubes to generate high pressure and high temperature steam. The steam will feed the turbine for electricity generation. The cycle finishes at the air cooling condensers, where the exiting turbine stream is condensed back to water. The resulting water returns to the beginning of the process, completing in that way a closed-loop cycle with zero fluid discharge. The plant will have 4 separate combustion lines, which will operate simultaneously and remain active 24 hours a day, 7 days a week. The energy produced by the Mexico City New Waste to Energy plant will be interconnected to the national electrical system and will distribute 965,000 megawatts per hour on a yearly basis to the Mexico City subway network to power the 12 subway lines. This energy is equivalent to the required for powering 120,000 homes. The plant will be equipped with state-of-the-art technology, available for treating flue gas emissions, thus ensuring compliance with environmental regulations not only in Mexico, but pursuant to the highest global standards. It will also be equipped with a real-time emissions monitoring system to guarantee the proper control of emissions within the allowable levels. The combustion byproducts are to be adequately managed and may be employed as construction material. This project complies with the highest quality standards to maximize energy recovery thanks to a more efficient management of urban solid waste.
Okay. So we can have later. You can have someone else is talking as well. Someone else is talking as well, right? Okay. So I think I have a few more videos later. You might want to have a look on different types of waste. Hello. Someone can mute the one that talking.
Excuse me, Sabita. Your mic is on. Sabita.
There is a few other technologies that we can have, and maybe later you might want to have a look on that. I can give the slides later to Dr. Isara so that we can have a read and I can browse through. So that's all. That's a summary for the key points, and with the future direction, I'm hoping that we are moving towards the development of these facilities. It's very interesting. It's having a very real challenges, and we were able to do this in order to save our environment. And with that, thank you very much. I'm passing back to the chairman. Thank you.
Since this morning, it has been a wonderful meeting. Currently in Thailand, it's time for a lunch break. Therefore, we would like to end the morning sessions and start the afternoon sessions at the next hour, which is at 1 p.m. in Thailand time zones.
Okay. Okay then. Yeah.
And if it is possible, could you provide your PowerPoint files for the both section, please, Professor?
Yeah. You want it now or you want it later after the second session?
Maybe after the afternoon sections. You can send it so they can they all can see the files.
Yeah, I will pass it to Dr. Isara later after the evening session. Is it okay?
It's okay.
Okay, thank you very much.
Thank you.
Thank you, ma'am.
Thank you. Okay. So I will be starting my presentation. Today I'll be sharing with you. I supposed to give some talks on the publication, how to write a publication with relate to the waste to energy. But from my point of view, it would be better if let's say we have a general overview, since some of you might not want to publish something on the waste topic. Maybe you want to post write something on the environmental effect or any environmental research or even the chemical engineering research. So let me make it broad so that you do have some ideas. This will be based on my experience. So it will be the journey of me publishing papers in WOS and Scopus. Perapat, is it possible for me to know whether the participant here, they do have the knowledge of going through the WOS or Scopus websites, or they don't have any basic knowledge on that? Mr. Perapat, are you there?
Yes, Professor.
Is the participant in this session, they do have the experiences submitting journals in WS and Scopus, or they are quite a new one, like a beginner?
We don't have that information from the participants.
Okay.
If the meeting is like anyone can join the meeting like that. Yeah.
Oh,
Allow
okay.
anyone to come.
Okay then.
Excuse me, we are basically new for the publication. We have not did the publication till now.
Okay. You are from PSU, is it? You are the student of PSU?
Yes.
Okay, so I'll be showing you as well what the website looks like later, so that you do have some experience on how to select the journals and which journals you start with and everything, things like that. Yeah, since you might be a beginner in terms of submissions of publications, things like that. Okay, is it okay?
Okay, thank you.
Okay, thank you very much. Okay, so we start with the first one. Okay, this is my outline for this evening. We start with the manuscript preparations, and then cover letter preparation. I will leave it at the back because I would like to show you the journal submission process and the common mistakes in journal publications and challenges in paper writing. I also will go through with you the online tutorials or online versions of browsing the WOS and Scopus website, so you know where to actually find a good journal and how to find a good journal for your paper. Okay. First of all, I will try to finish it early so that if you do have questions, just jot it down. Later, after we finish the session, maybe in 1.5 hour time, we can spend another half an hour to open for Q&A. So I can answer any doubts that you have. Maybe you are preparing some manuscript to be sent for publication. Maybe you want to know more about some few things that I haven't mentioned here. Let me know, yeah? So first of all, this is the structure of the manuscript that you will have. you will have a body with a title, abstract, introduction, methodology, results, discussion, conclusion, and reference. So I will go one by one, not mentioning what in details what need to be done and things like that. I will just highlight to you what are the important things that you need to note when you are preparing each of the section here. Okay, first of all, we go to the manuscript line first. Okay, before you start doing anything, you need to decide on what kind of paper that you want to have. Whether first you want to have a research paper, or you want to have a review paper, or you want to have a short communications. Yeah. So normally when you do experiments or you do some simulation work or even any research work related to your study, you want to opt for the research paper, which is a normal papers that comprise of the results of your study. You have a graph, a figure, table, statistics, things like that you actually obtain from the study that you have conducted. Review paper is, for example, for review paper, normally when you first start your postgraduates, especially when you have by research mode study, not the full coursework study, the research mode study. Normally we start off with a review paper, right? Literature review. So not to waste your talents of writing the review, I am suggesting that you are converting your literature review that you have read and you have write into a good review paper, because review paper will give a good impression and impact to your citations later, because when people cite, they will cite more towards the review paper rather than a research paper. Unless if the research that you did is a very novel one and nobody's did it and people are in trend of that topic. Let's say for waste to energy, people are talking about waste to energy now, or even hydrogen energy. Yeah, so there will be a trending topic on that particular research, and therefore that will increase the citation of your paper. What is citation? Citation is when people read your paper and they cite your paper inside their paper. That's what we call citation. So we to actually show the whether the research is good or not, normally they are looking at the citation of the paper. The more the paper is being cited, the good impact that the research is giving to the author. Means that the research is quite novel. Nobody have already done that, and it's actually trending. Yeah. For my student, normally I always ask them to do a review paper. For a master student, normally a very short review paper, the one that you can fit for Q3 or Q4 or even a Scopus index journals. And if you want to say what should be the topic, normally review papers, you try to dig in the review first. You need to start with a literature review and find the gap and find which part that people did not write much. Okay. Now, later, if you have any question on this review paper, let me know. I will go, I think, in detail later. We can have a thorough discussion on this review paper. Normally, review paper will be according to the journals. Some of the journals, they require a certain numbers of words. Pay attention on that, because you tend to write a very long review when you want to produce a review paper. Okay, normally that's happened to me as well. We are having a massive literature review. We are trying to compile and summarize, but intentionally, unintentionally, we are making it longer. Okay, because some of the journals, they only require a specific numbers of words and a specific numbers of figures. So you can't exceed that. Otherwise, they will return back to you, ask you to amend, or even they reject the paper. Yeah. Research paper, normally they do have a range as well, according to, some of them they don't have. In Elsevier, some of them they don't have the restriction. in some of the publishers, other publishers, they do have the restriction. Short communication, when to actually publish short communication. Short communication is a very, very short paper that actually tells the reader the novel invention in your study. You want it to be yours. You don't want other people to claim the work. Normally, you will start off with short communication, publish so that people did not replicate what you have did, and you can claim it as yours. So we can have approximately around 2,500 to 3,000 words with 4 to 7 figures. A very short one, actually, very, very short one. You can even have less than that, actually, depending on types of journal that you send your short communication. Yeah. For you to refer to your whether what is the requirement for that particular paper, you can refer to the guide for authors. I have highlighted in the red box here. You can refer to that to see the formatting of the paper, so that you know what are the standards, what are the formats that they require, what are the detailings that they are requiring from you. Yeah. Second, we go to the tips of title selection. Okay, title selection need to be catchy. For me, it need to be catchy. What does it mean by catchy? It means that when people in that area would like to read your paper, they found an interesting words or keywords that is in your title, because that keywords actually will, because when we search the paper, we are going to write the keywords. Okay, so the search that you obtain, the outcoming search, it will be depending on the keyword that you write, and the keyword of your title must be very catchy and attractive enough to actually encourage people to read your paper. Okay, please include, because when you do a paper, you do have a keyword at the bottom, right? So make sure that you include 1 or 2 keywords in your title, so that the keyword actually reflected the work, or the keyword and the title reflected the work that you want to carry out. Okay. Avoid acronyms, abbreviations, formula in your title. Try to avoid it, because I seldom see people putting abbreviation in the titles, acronyms, or even a formula. Except that when you have a catalyst, normally people do tend to actually put the catalyst name in chemical formula form, because it's quite long. Yeah, chemical can be spelled like ethanol, ethane, methane, diethanol, what, blah blah blah. So there will be a very long name for you to write everything. Normally people will do acronyms for that. Yeah. Things to avoid. Okay. Just to remember that please avoid the word of novel, new, and original, unless you're very, very sure that nobody's did it. It means that it's not an invention. If you invention and novel is different thing. Invention, you are replicating more or less a similar method to a different material or a different process. That more towards invention. That is not that novel. I would not believe that would be novel. Novel, if you can find a new chemical inside the process, like nobody has found that chemical or that compound in that particular product that you produce. That we can call novel. If not, better to avoid the words as well. Yeah. Simple and brief is need to be easily digested, which is people can understand what are you trying to focus on in that particular paper, but not a very long one. Yeah. Okay. The third thing would be the abstract. Okay. For abstract wise, you need to have a sequence. Okay. You need to have some background study. You need to have the objective or significance. In that first part, which is the blue one, background, information, objective, and significance of study. Some of the paper, they actually put a problem statement, some background study and a problem statement, then lead to objective. You can do that as well. Some of the paper, they straight goes to the objective after they have the background information. That can be done as well. Significance of study, some of them, they put at the bottom, which is after the recommendation part. Some of them, they did not include as well. So it's up to you, as long as when you read the first few statements of the abstract, with the first few sentences of the abstract, you can really digest what actually the authors wanted to deliver to you. Yeah, that would be the first one. Yeah, it should be very, let us focus on the content first and then we go to the criteria. The second one will be methodology. Please do not write everything, every single methodology that you use in the work. You just emphasize in brief, in like 2 or 3 sentences. If let's say, I think the maximum would be 4. I don't prefer to see lots of methodology. If I am a reviewer, I would like to see more comprehensive, concise of a methodology being put in the abstract, rather than you spell everything off inside the abstract. Yeah, as long as you know what is the process is taking place, what are the parameters being investigated, maybe a special features of your work using a different kind of feedstock or a different kind of material that you would like to emphasize, then it's okay. Just limit to 3, maybe 2, 3, or 4 sentences, depending on how long is your sentence. Yeah. Then put your most important results. Some other people, they just put everything and do not put trends. When I read some of the paper, because I've been reviewing quite a lot of paper, they put the trend discussion, the trend reporting. You do not report your findings in the abstract. You discuss the finding in the abstract. It means that the trend is increasing due to what? Yeah, the trend is increasing due to what are the justification, or what are the factual analysis that you can found. It's because of the loss of oxygen molecules inside the system due to whatever reasons are. That is kind of thing that you can put. You don't put the trend of yield is increased while the conversion is decreased. You cannot put like that. You just need to put like, increase because of what, then it's okay. Yeah, or it was found that the particle size is significantly influenced the process due to the what, blah, 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 blah. Yeah. Limit it as well. Do not put every single results. Just put the significant one that you think that it will be attention gather. It means that the first thing that people will read when you have a paper, they will read your title, they will read your abstract. 2 things. Yeah. So for your paper to be cited or for your paper to be referred, this don't need to be very, very attention gather. You need to like pull people to actually read your paper, because it's not fun to read a scientific paper. It's full of jargons that you might not know. It's full of very technical stuff that is not easily to be digested. So I believe that if you have a very good abstract, people will tend to actually read more, introduction and so on. Yeah. And last but not least, you need to mention your conclusion. What have you concluded for your research? And maybe you can recommend some few things that can be done in the future. Okay. So abstract for a review paper and abstract for a research paper is different. Yeah. In review paper, you need to highlight what is your research camp, what people have not been reviewed yet, what people haven't reviewed yet. So that is the thing that you need to highlight, so that the novelty of the review paper is that, like, people know, okay, what is the difference between this paper and the other review paper, so that it will be a catchy thing that people will tend to actually read more for your paper. Okay. Criteria, it should be impressive. As I mentioned, you need to make sure that when people read it, oh, I like this paper, so I will be going to read this paper, going on reading the paper from the introduction, from the methodology, even from the results and discussion, because it's very similar to my research maybe, or the information that I would like to have is in the paper. Yeah. Word limit, you need to have a word limit. Don't put it too long. It will be dragging and it will be not fun to read. And it must be self-contained. What does it mean? It means that you cannot refer to other figure to the abstract. Let's say, please refer to figure 1 in the introduction section. Do not do that, because it needs to be standalone, because some of the universities, they did not subscribe the publisher. So normally what we can see is only the abstract. So you can't refer to the main body, because otherwise it's very difficult for the person that read your paper to cite your paper, because sometimes we can also cite the paper by seeing the abstract, because we know that he did some certain things on this thing and he got this result. So you can cite the paper even though you don't have the full paper. Take 3 or 4 keywords in the concise abstract. You need to have your keywords that you put at the bottom in your abstract. So any question for now? Okay, if you don't have any question, we are going to proceed to the common mistakes that people always make in the abstract writing. First, my first concern would be English. English will lead to a rejection. So better if you can have someone to read, someone that is good in English to read your paper first, especially on the introduction part, because when the paper comes for a submission, the first thing that people will read is your abstract before they will pass down to the associate editor, because once your paper is submitted, they will go to the EIC, which is editor-in-chief. So the editor-in-chief will then delegate the paper to the associate editor. So before he or she delegates the paper, he need to make sure that the paper actually fill or comply the scope, got a good English, is easy to be read, and contains a novel finding. Okay, that is 4 things that always people see. Normally in Q1 WOS, the rejection will be based on English and the novelty. Once your English is worse, even though you have a very good novelty of research, they will reject your paper. Yeah, if they can't understand what you have written in your abstract, then it's bye-bye for you. The second thing would be the novelty. Please make sure that you emphasize the novelty of your research in your abstract, so that people will confident that this work is novel, it can be further evaluated, and it has potential to be published. Yeah. Findings is not properly reported. Do not put high, low, small. You need to put numbers. You do have a specific numbers, like the conversion is 90%. The yield is 90%. You do have a number. So please put the numbers inside the abstract if possible. If not, let's say maybe you want to describe of some other things about the particle size maybe. So elaborate on that part in detail, but try to make sure that what we can see for this word is not measurable. Yeah, it's not measurable. It cannot be measured. So please avoid putting words that cannot be measured. Yeah. Things to avoid would be diagrams, table, references, abbreviation, and equation. Do not abbreviate as well in your abstract. Okay, results and discussion. You keep mentioning of the result in discussion that is not inside your result and discussion part. So make sure you don't do that. Yeah, make sure that the results that you put in your abstract, they are detailedly elaborated inside your main text. Yeah. Okay, now we come to the next one, which is producing a good introduction. So first, this is the sequence whereby you do have a synopsis of literature review, you highlight the importance, you highlight the problems, you highlight the insufficiencies of the previous studies, highlight the knowledge gap, and stating the purpose of the research. When I first wanted to do a paper, first of all, it will be from broad issue to a narrow issue. First, you describe on the topics, what this topic is all about, what are the things that has been done on that particular topic, why you want to carry out, why people are carrying out the research on that particular topic. And then slowly you need to zoom towards your problem. Maybe you start with a general problem. Let's say you are talking about waste. Okay, you are okay, let's say I'm talking about hydrogen energy. So first of all, I'm telling the audience about the hydrogen energy, then the technologies to produce hydrogen, and then what will be the general problem statement, why hydrogen has been adopted as one of the alternative energy, said about the greenhouse gases and the emissions, pollution emissions and everything. And then you zoom into the process. Okay, what are the process that can use in that particular study? Focus on the process that you want to do, and then maybe you list out the drawback of the process, what you have experienced in that particular process. Zoom into the problem statement. Okay, that would not, maybe you can have a more detailed problem statement if you zoom into, like say, like me, I'm doing catalysis. So I zoom straight away to the catalyst. What would be the problem with the catalyst when you run the technology that you have mentioned? So it will be from very broad issue towards a very specific problem statement. Yeah. So when you highlight the problem statement, you need to highlight what are the things that has been done in that particular problem statement, not the general one. That particular problem statement, the specific problem statement that you have mentioned. Okay, there must be somebody that has done something on that problem. But from like listing every single literatures that actually concentrating on that problem, you will find that this part has not been done yet. Yeah? That this part has not been solved yet. Okay, from the part that is, let's say I'm talking about catalyst, the catalyst still deactivated when you have a high temperature, or when you have a high loading of feedstock, or when you have insufficient temperature. Yeah. So when you have the problem statement, you definitely widen your research gap. You can see, oh, this is my research gap. This is what I want to do. Therefore, it leads to the purpose of the research. At the end of the introduction section, you should have one paragraph mentioning, due to these insufficiencies or due to the lack of knowledge or literatures on this area, the purpose of this research is to do what? And then mention using what and what expectation that you have in that particular research. You can have a sequence like that, or you can have any other sequence, but normally at the end of the introduction section, the last paragraph will actually highlighting what are the things that you want to do. Okay. If you have any question, just drop by in the chat box so that I can answer straight away. If you don't want to open your mic, you can just type the question and I can just answer the question. Yeah. So finish on the introduction. Okay. Some tips that you can have for introduction. I think when I review a paper, normally the thing that is lacking is the research gap and the problem statement. They do have the problem statement, but they do not spell off the specific problem statement, because when you talk about doing research, you are trying to dig around what are the things that have not been done. Normally, if let's say if you want to produce hydrogen, right? Definitely, there's lots of people producing hydrogen. If you want to use a certain technology such as gasification, a lot of people have done gasification. So what else is the problem? What are the reoccurring problem in the process? Definitely there will be something that has not been solved. There's something that is still remain as a problem, even though there's so many things that have been done. So that is where you actually find your specific problem statement. Abstract. Later I can go back to the abstract. I will finish off this one first, yeah? Okay. It need to be recent and relevant. Do not just dump everything inside. You need to have sequence. Do not jump everywhere in your introduction. Some of you, sometimes they are talking about the gasification and then they talk about the catalyst and they go back to the gasification. They are not sticking to the same topics and narrow down the topics. You need to be consistent when you write, and you need to have a flow. The most things that lacking when I see when the authors submit the paper would be the research gap. They did not mention clearly the research gap. The reference is not within the recent years. I would just like to highlight few things. Let's say normally when I would like to write a paper, there will be comment from the editor-in-chief saying that I need to cite few journals from that particular articles or particular publishers or particular journals that I would like to send my paper. So please do at least cite few papers from that particular journals that you intend to submit your paper. Okay, have a few recent one. Try to include in your introduction section. That will be much more appropriate, because I'm sure they're asking like that to increase their citations and things like that. So normally without being told off, I normally will cite few articles from that particular journal article or journal title, because definitely when we put something in that particular journal, we are already sure of that this kind of topic is acceptable in that particular journal. That's why we need to have evidence. The evidence is like we are citing other papers from the same journal similar to our research work, so that we know that the scope of the work that we have is suitable with the scope of the journal. Okay. Introduction should not contain your results. The other person's result can, your result cannot, or even the discussion of your results in the journal. Okay. Cite broadly. Do not cite one specific region. Like you are coming from India, you are only citing people from India. That is not the way. Yeah. You need to cite broadly. Cite some people from Africa, some people from European countries, some people from the Asian countries, so that your reference will be diverse. Okay, methodology. Okay, these are the elements that should be in your methodology. So methodology should consist of materials, models, and assumptions. Normally, what type of material that you use, what are the let's say you are using experimental work. Describe a bit on the experimental. If you are doing modeling, mention the types of mathematical models or simulation models that you use. Describe your equipment. If you have a setup, just draw the setup and include in the paper. And then describe in detail your experimental or even the characterization method. And make sure that you mention about the data reproducibility and accuracy, because people would like to know whether the data that you have produced is reliable or not. Because sometimes if you don't repeat the experiment, you are getting a different answer, right? For the second or the third one. So you need to make sure that you are telling the reviewer saying that, okay, I confident with the results and I have repeated it few times for with the same condition. So, or you state the numbers of duplicates or triplicates that you mentioned or you conducted with the data. Normally, going a bit on the results, normally we will put the reproducibility results in terms of error bar. So let's say that you are having error bar at the back or at the bottom on the discussion part, but you did not mention the data reproducibility and accuracy. It might be having some concern from the reviewer saying that you are actually faking up the error bar itself. So better to be caution on that. And experimental details, do not forget to actually draw the setup, draw the table. If let's say you are conducting design expert, doing some simulation studies or optimization studies, do not forget to attach the table of experimental conditions or even a sample, the table of sample characterizations, things like that. Please, if let's say you are taking the method from other people, please cite the reference. If you are modifying the method that other people have did, you can say that this method is originally from who in the bracket and maybe the citation with a certain modification. If let's say you did some modification, you need to mention that. Yeah. How often we have to cite in the introduction part? It depends actually. It cannot be too less, it cannot be too much. Do not, the thing that people doesn't want to see is you have more than 3 or 4 citation in one sentence. Do not do that. Normally, people would not love to see that. Reviewer will ask you to amend on that. As long as it's actually within the scope, as long as you are citing the recent one, then it's okay. But do not have it too less. Like less than 20 would be too less for a research work paper. Maybe more than 100 would be too much. Yeah. So you need to, it can be varies according to what information. Some of the research, there's a lot of people conducting the work on that particular area. So easy for you to find a review or an article to be referred to. But some of the work is very, very difficult to get literatures or to refer to somebody. So you might have a less number of papers that you can refer. Yeah. I hope I am answering the question. Tips to write a good methodology. Methodology should have references, as I mentioned, should have validation. As I mentioned, you need to produce a reproducibility part. You need to show the novelty, as if not in terms of the words, maybe in terms of how you write your methodology. Do not repeat details in your methodology part. Make sure the things that you think is too general to be informed in the paper, you just put inside the supplementary data. normally if let's say you are taking method from somebody else or you are referring to your own paper, the previous paper, better not to spell off everything inside the paper. Just ask them to refer to a paper, and then if you did a modification, just mention I did some modification with the modification in which part. Yeah. Okay. Any question? Okay. If not, I'm going to proceed on the results and discussion. On the results and discussion, these are the things that we might want to put in our result and discussion. This is things that they should be inside your result and discussion. Okay, when you do a discussion on a certain figures or a certain tables, report the trend first. Okay, you see that this is increasing with the increase of this, and this one is decreasing with the decrease of this. This is actually flattened out at the hour of 3. This is jumping to the reduced to a certain number after 1 hour, things like you are reporting. When you say it like that, you are reporting. You are not discussing. When you are discussing, you mention why that is happening. So you need to mention after you have report, you discuss. This is the temperatures is falls below 200 after 2 hours of reaction. This is the same happen to all catalysts. This is probably due, if you are not sure, you can say that it's probably due to what, but you can actually support the statement with a finding, like you have a finding, you have a characterization finding. For example, you can say that this results is in accordance with the results from the analysis of X-ray, maybe X-ray or even the GC. So you can say that it is in agreement, or let's say it's not in agreement, it's totally different. Then you can say that this is in contrast with which results from which literatures and why is it happening. So you need to have that why. That why is your discussion. Without that why, you are only reporting your paper. Yeah. In that discussion, okay, please dig your results towards a very depth analysis of the work. So why is it happening? This is happening because of this thing. This thing is actually due to what. This is influenced by blah 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 blah. You have a detail from the broad issue until it's narrowed down to a detailed issue. Figures and tables. You need to have a proper table. Sometimes the tables I've seen, they have a very small caption. The labeling of x-axis and y-axis is very small. The bullets is cannot be differentiated because last time you did it by color. Then when you print out, it's only black and white. I'm advising for you to actually, if you have a graph, more than one graph for more than one line per graph, please do a line with different bullets so that if you are printing, because most of the researchers, if they wanted to print it, they will print it black and white. So it's impossible to differentiate the color if you have a shapes. If you have a difference in shape, in color. You need to have a different in shapes in terms of its bullet so that you can differentiate the trending. Yeah. Second, the third thing, the fourth thing would be the negative results. Okay, understand that when you need to understand that when we conduct research, it's not necessarily that we are getting a positive result. Sometimes they are having a negative results. You can report that, but do not highlight on the negative results. You can report on that and justify why that is happening. What are the references that are actually having the same findings, so that you are being supported. The one that you did is similar, and you can the statement that you made can be supported with other arguments. From the results as well, you can actually see whether the objective is being achieved or not. Okay. Okay. This is common mistake that people has already made. Okay. Poor result interpretation. That is quite crucial, I think, because some of the results, I can see that they are reporting on the advantages of that particular system, but later we can see that the advantages is also a disadvantages of the system, where the result is actually contradict. It doesn't really sync. Your results is contradict. In one part, you are saying that you obtain this because of this, but in one part, you are actually denying that you are getting that results because of these findings. So you need to make sure that the results, the interpretation that you made is correct, rather than you just simply referred to any journals and just found the review and just put inside the system. Okay, the way the graph is being presented, okay, please be careful. Sometimes they do have a very horror presentation of graph that if I am a reviewer, I'll be definitely rejecting it without seeing the content. Even though your content is good, but the appearance of the paper is very bad, it's not giving a credit to the author at all. So make sure before you send, you make sure that everything is in a smooth transition, a smooth surface, and it's easy to be read. Yeah. Okay. One thing that I would like to highlight, especially when you did a review paper, do not forget to actually code the references for the particular tables. Oh, sorry, particular tables. Yeah, tables and figures that you have opt from other people's work. Okay. You need to ask permission for that. Yeah. After you are asking the permission, then you need to cite at the bottom of the figure saying that this paper is being the copyright of the permission. Sorry, the permission for the copyright is obtained from blah blah blah. Where is it obtained and when is it being obtained? So the readers aware that one is not your paper and your figure, and you are quoting somebody else. Better if the figures or the table itself, you request it from the what is that, the publisher. You need to actually, like Elsevier is very straightforward. You can have a button whereby you can actually request for a publisher permission to actually publish the figures or the tables. For the rest, some of them they requires you to email, and some of them they just granted it by filling up in the system. Yeah. Missing references. Do not miss your references. You need to be there inside the list of references. So make sure that you are putting every single thing in that particular paper. Yeah, we finally arrive at the conclusion. There's quite a number of things that I would like to discuss. This is only the paper preparation first, the first part. So there will be some tips of having a good conclusion. You first mention what you have done, which is maybe have one sentence on what studies you have you conducted in this paper, and then highlight your results and finding from the paper and summarize achievement and consistent. It need to be consistent with the objective. So make sure that you read back in the first part, which is the abstract part. Sorry, the introduction part. You do spell off your objective, right? It need to be tally with the summarization that you have in the final form, which is the final conclusion. Yeah. Highlight the originality. Make sure that you are mentioning the novel thing that has been conducted in that research. Research must be novel. It need to be new. It need to be something that you have innovate. You cannot be something that people have done. So it need to be new, and you can spell off it in the abstract paper. I'm not sure whether originality, you need to mention somewhere in the conclusion the originality of the work so that it reflected in all parts, especially the abstract, the title, and the conclusion. Okay. Focus on the significance, why research is very significant and why people should have conducted a research in this area, and suggest what you can be done next to actually improve the research. But in this last part, it's just it's not a compulsory. You can actually play around with the information that you have to make sure that the flow of the point is smooth. Okay, this is the last one, is it? Yeah, the last one for the paper. Producing a good references. So definitely when you talk about references, it need to be recent. Yeah, please cite the most recent work. Please cite the main publications that done on that particular topic. Cite a high impact factor journal. Do not just cite conference proceeding. It's not going to be much valuable. Cite the WOS Q1 and Q2 paper in your references. Avoid self-citation in your paper. Avoid excessive. It means that you can have few self-citation, the one that very relevant to you, and then the rest you don't actually do too much self-citation. Means that you are citing your paper from a previous paper in that particular journal in few other places. It's not going to be possible. Please bear in mind on that. Yeah. Avoid excessive publication within the same region. So you need to avoid papers from Southeast Asia maybe, or even Malaysia, or even Thailand. You need to be very so that the research that you have conducted can be applied in different countries as well. Okay. Is it possible for me to take a 5 minutes break? Maybe 2 or 3 minutes break?
Professor? Professor? Your microphone is off.
Yes, I'm asking for like few minutes break.
Oh, okay. I'm sorry.
I will come back in 1 minute time.
Okay.
Okay, we continue with the next one. Content for a good cover letter. So after you've done with your manuscript, you need to produce a cover letter. Okay, very important for you to highlight everything inside this cover letter, because this will actually been read by the EIC, and you need to actually highlight the novel statement, or giving a novel statement on why this work need to be published in these particular journals. Okay, so mention about the numbers of figures, tables, word count, the title and the author informations, the suitability for the selected journals and the readership, and declaration of interest statement and credit authorship contribution statement. So the last but not least would be the suggested reviewer. Okay, suggested reviewer, just a bit tips from me. Some of the journals, they do follow the suggested reviewer. So you maybe you put someone that actually good in the area, and someone is not within your institution, someone that is reliable to give feedbacks to your work. Do not just randomly choose people. You might want to see their publications before you actually nominate the reviewers. It can be among your friends, but it cannot be within the same country. Normally, we appoint somebody from different institution and from overseas. So there will be maybe 2 from the same countries and 2 from the overseas countries. Yeah. Okay. Some of you also been wondering. There will be different types of publication, whether you have a journals or proceeding. So which one should you choose? Okay. Normally, if it's for a research paper, a very long research paper or a very comprehensive research paper, definitely I will be opting for the journals. And for a very short findings, or even for my final year project undergraduate research, I'll be opting for proceeding if the work is not that too deep. Yeah, but be careful on these proceedings, because some of them, the one that you would like to target will be a scopus in that proceeding. Yeah, because they have some points that it can be cited and your scopus index can be improved. Okay, but remember that they sometimes they lost their scopus status from time to time. So you need to check in the system. Later I will show you where you can check from the website on the status of the paper. We can see later, yeah, for this one. And which one that actually easy to be published? Definitely, I think proceeding will be easier to be published apart from journals. And journals, they do have rankings. They have quartile, ranges from Q1 to Q4. They also have a scopus journal. So it depends on what you want to select, and what is the quality of your paper. If you think that the paper deserve to be in very high impact journals, then proceed. If for my case, normally I will go to the high impact journal first to test whether the paper is sufficient enough to be considered as Q1 or Q2 papers. Yeah, because from there, sometimes you will getting comments. Okay, that comments is very beneficial because sometimes maybe that is the thing that people are looking in your paper. Yeah, people would like to see or you can actually improve the paper by seeing the comment that you can have from the review. Yeah, sometimes it has a dash rejection where you can definitely being rejected after you send the paper. That will be called as a dash reject. You can also being passed through the review process and be rejected. That will be another possibility. Another possibility that you are getting a revision, but major revision, it might lead to a rejection later if you are not addressing each of the point accurately. And you can also have a very minor corrections. Normally that would not be the case for the Q1 and Q2. Definitely you're getting like a massive of comments for a high quartile journal. Yeah. For proceeding, normally you have the conference that actually come up with the proceeding, like in Malaysia as well, and in my faculty as well, we have two conferences that we have both proceeding and journals. We are encouraging some of you that would like to participate to actually send the papers to our conference. We have one with SC 2023 and another one with Recase 2023. Both of them have secured a good WS journals as a special issue, and they do also have the proceeding that you can publish with. Okay, this is some of the elements that you need to maybe look at when you have a paper. So you need to look at the amount of time required for the paper to be published. Some of the journals, they took about a very long time to be published, and some of them they just process in 2 weeks time and it's settled. Okay, I can say that when you have a higher range of like a higher quartile of journal like Q1, Q2, the time that they require to process your journal or your submissions will be much shorter compared to maybe a Scopus journal or even a Q3 or Q4 journal. That would be my experience. Maybe some of the Q3 and Q4 papers, they do have a shorter time. I believe some of them do have, but most of them, they required a very long time to actually get until the acceptance of the paper. Maybe it takes more than half a year, maybe it takes 1 year, maybe it takes like 3 months. But for a Q1 paper, if your title or if your manuscript is not up to their standards, they have a dash reject in like the shortest I have will be 1 day. The longest that I have for Q1 would be a week. So within a week, you will know whether your paper will be proceed to the reviewing process or you are being rejected. Yeah. A second one is where to publish. So there will be two databases that we have, which is Scopus and Web of Science. Normally, Web of Science is inside the Scopus. It will be part of Scopus, but they will be very specific, and it is having a higher ranking level compared to the Scopus publishers, Scopus database, sorry. So if you have a very good quality papers, you can opt directly to a Web of Science journals, because the Web of Science journals, normally they are also Scopus index, but not every single Scopus Index journals is a Web of Science in Web of Science database. Okay, this is where to publish. Okay, when you have a paper, you like to know where should you publish. So the first thing that you would like to see is what kind of journal that you can publish. So later I will show to you on how to search for a journal within the topics. Yeah. You might want to write the keywords so that you can't find the journals. And from the journal itself, you can find the name of the journals and you can find the details. Okay, later I'll show you the Web of Science one. And then this is WS as well, whereby you can see in terms of the list of the potential journal that you can publish. Okay, be careful on this. Normally, you do have the expiry of Scopus Index publications. So you need to be very careful so that you are not publishing in the one, because normally you targeted to publish in a Scopus Index. But when you didn't realize that the Scopus has been withdrawn, normally if the Scopus is there, you will find that from 2010 to present, then it is covering until up to date. But when they have the statement of from 2009 to 2021, it means that it's not Scopus Index anymore. So you can see that this one, I searched this one last year. So that it means that IOP conference series from 2009 to 2021, they are Scopus Index, but eventually because of the low quality of the paper, the Scopus actually withdraw the status and they are not Scopus Index anymore in year 2022. Okay. This is where to publish. I will show you the browser later on this one, on how to check. Okay. You can also have a list later. I will show you as well this one. Okay. Apart from the journal, where to publish, another elements that you want to see would be the acceptance rate. So the higher the acceptance rate, the higher chances for your paper to be accepted. But you can see from here, Catalyst today, the acceptance rate is 65. This is why. This is because normally they don't have this much of acceptance rate. But this Catalyst today is a paper by invitation. People can only submit in this journal from the invitation by the journal editor. That's why the acceptance rate is quite high. Okay. Apart from that, you can see that the other journals, they do have quite a low number of acceptance. The lower the acceptance rate, the more less papers that can be published. It might be that they don't have much issue per year. Some of them they only have one issue per year. Some of them they have two. Some of them they have four, according to the journal editorial board. Yeah. This is some of the journal selection tool. I can open one for you as a view later, so we can see how we can find the suitable journal for your paper. Okay, this is the common rejection that you can have for a paper. So novelty is not significant. Q1 will definitely reject your paper. If the work has been done by somebody else and you just replace it with different catalyst or different feedstock, definitely Q1 people are not going to accept it. So you might you might highlight things that other people did not do yet. Similarity. Okay, I need to highlight to you when you put your manuscript in the system. Normally, when you check the plagiarism, you are checking we are checking, like Malaysian, we are checking using Turnitin. I'm not sure what what are the tools that being used in Thailand. But in Elsevier or even in Springer, in ACS, they're using softwares named Authenticate. This software is much more stringent compared to the Turnitin. It can lead to a little bit higher percent of plagiarism when compared to Turnitin. Yeah. So if let's say you want to have a good reputation on the similarity index, when you put inside the Turnitin, it must be less than 15% and not more than 1% for single source. It means that for single source, it must be less than 1%. Yeah. Cover letter did not spell off the novelty statement. Novelty statement is very important because this will lead whether your papers is good enough to be published or not. Okay. English, please, if let's say you are not good in English, please send it to the proofreader. Otherwise, you can use the AI tools. There's lots of AI tools that can be used to rephrase your wordings or to correct your grammar. Use that if you are not willing to actually spend your money for a proofreader. Okay. The journal scope, do not forget to check the journal scope. This is very important, as this will actually lead to rejection if you are not meeting the journal scope. And finally, the most simple thing, the formatting and references. Make sure that it is in a very good formatting. Do not have different font, different colors, or different size of font in your manuscript, because this will actually annoy the reviewer and lead to rejection. Okay, so this is some of the challenge in paper publication. Having been rejected again and again cannot be the fear factor for you. I am like me, I'm trained to be rejected again and again until I've managed to submit in one Q1 paper. Definitely, I would try at least up to like 7 to 10 times in the Q1 paper and improve. You cannot just send and then you got comment, you just send the old version to the next journal. Improve the paper according to the journals requirement. Some of them, they pass through the reviewing process. So you can have some comments to actually improve your paper. Or if let's say it's been dash reject, they will spell off what is the missing part. But normally dash rejection doesn't give much information. If you have a dash rejection, then you can send the same manuscript again to the next journals. But if you do have comments that you obtain from the previous submission that has been rejected, try to address some of the comment, if not all. I know that some of the comment requires you to spend some money to do the analysis and things like that, but it's okay. Things like that can be left first, but later if let's say you got a revision and they ask you to resubmit the revision, you must try your best to accommodate with all the information needed for the process. Identify alternatives. You can use the journal finder to determine the alternative, and there will be the most hurting part would be the comments from the reviewers. Some of them are very harsh. They just condemn your work, which they didn't know that you are spending a lot of time doing the experiments and everything. But it's okay. You need to be very steady. You need to be very not giving up. You treat it as just a comment. Do not take into heart, and then just proceed with the submissions. Yeah. Okay, with that, I would like to show you how we can actually use the Web of Science and Scopus. I will share the slides to the Dr. Izara. Dr. Izara will pass the slide to you later. Yeah. Let me stop sharing. I need to share again so that I can. That is my. Wait for. I need to open one. To share my screen. Sorry. I'm sharing my screen right now. I'm sharing the whole screen, right? Is it correct? Can someone?
Professor, right now I cannot see your
screen.
Your share screen. Yes. And one more thing, Professor, could you
I'm sharing my desktop screen now.
Yes.
Can
yes.
someone respond to me?
We can see it now.
Yes, it's seen.
Hello?
Hello, Professor.
Can you screen my Google screen now?
Yes, we can.
I can. Okay, so I'm going to open my website because it's under a library. So we are going to see from the library now. Sorry. This is.
Excuse me, Professor.
Yes.
Could you attach the file in the Zoom chat box, please?
Attach the file. Which file?
The PowerPoint file that you shared to us.
Can I pass to Dr. Izara because I need to email the previous one as well. Is it possible for Dr. Izara can pass to you or it's not possible? I need to put inside the box.
Yes, there's a button that can attach your files.
Can I do it later because I haven't finished it yet?
Okay. Thank you, Professor.
Okay. So I try to open one, the WS. You can see this one, right? Okay, this is Web of Science. So from this Web of Science, you can actually browse any journals that you are interested with. And let's say you have publication titles, energy. Okay, ACS energy letters. You can see my screen, right?
We can see your screen, but not the PDF file. Not the PowerPoint file. Right now we are seeing the folder files. Yes.
Folder file. Okay, for a while. Let me share. Can you see my screen?
Oh, we can right now.
Okay, so I'm sorry, I thought that you can see just now. Okay, now let me begin again. So you need to enter the WAS. In some of the universities, you need to enter by the library website. So mine was from the library website. I'm not sure how PSU, where students from PSU can access this, but I'm fully certain that there will be some platform for you to get the database. Yeah. So I'm clicking to the Web of Science. You even can register yourself if your institution is not subscribing to this one, so that you can browse some few journals here. Okay, let's say you have this one. Okay, you just click on this journal. They will give you some information. What are the impact factor? What will be the quartile? What would be the citation indicator for that particular journal? So if you have you have already a targeted journal, you can use this one to refer to. Okay, in this case, you have already know, okay, I want to publish in ACS energy letters. So I need to know a bit information on the quartile, on the impact factor. So I can just click on the journals. Let's say that you don't have the, the name of the journal, okay? In that particular case, we can go to the journal citation report, yeah? This is, I cannot paste this one since this is easy proxy. You cannot access when you are outside of the university. But you can just Google Journal Citation Report, Web of Science. So there will be some link that will lead you to this one. Okay. So in this one, you can browse according to either journals, either category, or the publishers. Okay. Normally, I will go by categories. If let's say I would like to see potential journals that I can put my paper in. Okay. Okay, let me see. Let's see. I take this chemistry and I take an energy as one of the category. So for the energy and fuels, we have two, whether it's addition of SCIE or ESCI. So normally I will opt for this one. For this one, they will give a list of journals that is under this topic, which is energy and fuels. So you can choose any of this to publish your work. They will have already give you the journal quartile, the impact factor. I'm sure impact factor is where? This one. 2021 impact factor. It will going through from Q1 until you have Q4 at the end. Yeah. A speech will be Q4. So you can choose any one of this for you to publish your paper. You remember, the higher the quartile, the more difficult for you to publish in that particular journals. The higher the impact factor, a bit more difficult for you to publish in that particular journals. So let's see if you like to open this one, please click one. And then in this particular section, you also can see what would be the performance of the journals, what would be the impact factor, what would be the trend of the impact factor, what would be the journal citation indicator, what would be the whether it got an open access or not. This is very important because some of the journals, they only allow for open access. It means that you need to pay for the journals. So you need to be careful to publish in something that you are capable with, because open access, normally the price would be like thousands of Malaysian dollars, Malaysian ringgit. It would be like, I'm not sure in Thailand's currency what would it be, but in Malaysia's currency it will be maybe in USD it will be like 2,000 USD. So approximately that amount. It can be lesser, but the more prestigious the journal, the higher the open access price that you need to pay. Okay. What else? Let me see the PowerPoint. What else that I should show you? This is the course scopus. This is the WOS. Okay. Okay, that would be for WOS. So if let's say you don't have account, you can always use the WOS one. Because journal citation reports, I believe it's only allowable for those who subscribe. You can't see if you don't subscribe to WOS. If your institution did not subscribe for WOS, you can't see the journal citation report. But you can always see the WOS one. This one. Sorry, this one. Yeah, you can always search from here, but might be that you are not able to see the list. You only can search for the journals that you acquired to see, like you are searching for energy and fuels maybe. So you just energy and fuels. Okay, so you just search for it and then they'll coming up here. You can see the information here. This is the one that you can see, but normally you can't download anything when you are not being subscribed, but you can register. It's not a problem because I've tried before. On the scopus, let me see on the scopus. Okay, when you have a scopus, Same with WOS, your institution needs to subscribe it so that you can download the document from the Scopus. You can have a sources, and then you enter your subject area. This is when you want to see the list of journals that is possible, yeah, for your this is too large. Let us see, let us reduce it a bit on maybe we zoom it to energy, renewable energy. Okay, apply. Maybe energy can apply, and then you will be giving a list of energy source title and the site score. Okay, in this Scopus, the site score, the index, the quartile will be different from WS because they are different database. So but most of this, they will have their database in the WS. Normally, everything in WS, they are Scopus index because Scopus index is a higher ranking of database compared to the Scopus. This is the site score ranking. For Scopus index, you can refer to the site score, the SJR and SNIP for the references. The higher the score for this one, the better the journals. And this is how they actually do a calculation on the site score. Yeah. Actually, they do have a quartile, but I'm not sure where they did put the quartile. Might be somewhere. And before I forgot, you need to see until when the coverage is. So be careful, make sure that this is in present form. Otherwise, it might not able to be in Scopus anymore for that particular journal. Let us see for the last one. Try to see. Yeah, I'm not sure whether they are still. I need to go further. I need to put maybe 200 here. See the last one. Okay, the NE is already NE. This one, they don't have the numbers yet. Let us see the page before. Okay, let us see one of this. I'm not sure can find something here. Okay, in some of the cases, they did not put presents. They put 2022 as the latest one. In this particular case, you need to contact the because sometimes because the journals is not really established, they did not put two presents because they're afraid that the quality of the journals is not up to expectations. So for you to ensure whether the journals is still Scopus index or not, if let's say they are still quoting like this, which is the recent year, last year, you need to ask the editor-in-chief. Let us see another paper. This one is also up to 2022. In some of the paper that they are confident with, they are going to put two presents. So you can know that they are still Scopus until now. Once they put the the numbers or the numbers of years, it might be a bit fishy that you might want to actually check whether it is still a Scopus index or not. Like this, they are also already not Scopus index. They are also putting here coverage discontinued in Scopus. So beware of this. Make sure you did not wrongly select the journals. Yeah. For what else that I haven't mentioned? I think I have covered most of it. Is there any question? Okay, I will share the slides here. Is there any question so that I can answer for now? I have sent the slides in the chat box. Later you can download from the chat box. Do you need the other slides as well? Yeah, the slides I need to amend something. So if let's say you need that slide, I will pass to Dr. Izara. You can contact Dr. Izara to get the slide. Okay. I think that's all for my presentation. I don't think there's any question anymore because I haven't received any question in the chat box. Thank you very much.
Thank you.
Bye-bye. Yeah. Hello, Rapat?
Yes, Professor.
Yeah, I've already finished.
Okay. Shall we end the session then?
Come again?
Shall we end the session?
Yes, you can end the session.
Okay. Today, on behalf of the Dean of Songkhla University, we truly appreciate the wonderful lessons and advice. Once again, we would like to sincerely thank professors for the special program and thanks all the participants. We hope that everyone will continue to participate in our future projects. Thank you.
Thank you very much.
Thank you.